There are places where time seems to have stopped, but the questions never did. Towering temples, silent pyramids, forgotten cities, and walls of stone still stand exactly where they were raised thousands of years ago, as if waiting for someone to finally understand them. They have survived storms, earthquakes, wars, and the collapse of entire civilizations. Yet the knowledge that brought them into existence has largely vanished. Every crack in the stone marks the passage of centuries. Every hidden chamber promises another mystery. And with every new discovery, one thing becomes increasingly clear. The ancient world is not becoming easier to explain. It is becoming more extraordinary. Tonight, we journey through the monuments that continue to challenge history itself. Beneath the fertile plains of northern Syria lies Ebla, Tel Marduk, a Bronze Age city that appears to have been built over the remains of an even older landscape where every generation reshaped the ruins left by those before it. Discovered in 1964 by Italian archaeologist Paolo Mathiei, and identified beyond doubt after the excavation of thousands of cuneiform tablets in 1974 to 1975, Ebla quickly became one of the most important archaeological discoveries of the 20th century. Yet, the greatest mystery is not its archive or its kings, but how a city constructed largely from mud brick could survive repeated destruction, rebuilding, and burial for more than 4,000 years, leaving behind architectural puzzles that modern engineering still struggles to fully explain. Excavations revealed that the famous Royal Palace G stood on an artificial terrace formed by centuries of earlier occupation. Rather than clearing away the remains of previous settlements, Ebla's builders repeatedly leveled collapsed buildings, compacted the debris into stable platforms, and constructed new monuments directly above them. This cycle continued for well over a millennium, gradually creating the enormous archaeological mound known today as Tel Marduk. Every new palace, temple, and defensive wall therefore rested upon the compressed remains of older cities, making Ebla not simply a city of the Bronze Age, but a monument literally built upon forgotten worlds. Even after decades of excavation, archaeologists have exposed only a fraction of the mound, leaving much of its deepest history hidden beneath later construction. The most remarkable structure was Royal Palace G, dating to approximately 2400 to 2300 BC and covering nearly 15,000 to 20,000 square meters. At first glance, its construction appears surprisingly ordinary. The walls consisted primarily of sun-dried mud bricks resting on limited stone foundations, materials that would normally deteriorate within decades if exposed to moisture. Instead, large portions of these walls remained recognizable after more than 4,300 years beneath layers of collapsed architecture. This extraordinary preservation remains one of Ebla's greatest engineering mysteries. Laboratory analysis has identified mixtures of clay, silt, sand, straw, and organic fibers within surviving bricks, but no single formula fully explains their exceptional durability. Some researchers suggest that carefully selected clay minerals produced unusually strong bricks, while others argue that repeated cycles of drying, maintenance, and rebuilding gradually strengthened the structures. Even so, no modern reconstruction has completely reproduced the longevity demonstrated by Ebla's surviving architecture. The scale of the palace deepens the mystery. Walls often exceeded 2 meters in thickness and supported multiple stories, wide halls, administrative offices, storage rooms, and ceremonial chambers. Thousands of heavy ceramic jars filled with grain, oil, and wine would have imposed tremendous loads on floors and supporting walls. Modern engineers understand how such forces are distributed through reinforced concrete or steel frameworks, but Bronze Age builders possessed neither. Instead, they relied entirely on carefully proportioned masonry, compacted foundations, and architectural geometry. Exactly how they calculated these structural relationships remains unknown, because no architectural plans or technical manuals have survived. The palace demonstrates that Ebla's builders understood practical engineering principles far beyond what simple construction techniques alone would suggest. As excavations continued, another astonishing discovery transformed understanding of the city. More than 17,000 clay tablets and fragments were recovered from the palace archives, making them one of the largest collections of written documents ever found from the 3rd millennium BC. Remarkably, the archive preserved its original organization because a catastrophic fire baked the tablets while wooden shelving collapsed around them. Since the shelves fell largely in place, archaeologists were able to reconstruct how documents had originally been arranged according to subject, administrative department, and function. The archive therefore preserved not only written records but also the physical layout of one of humanity's earliest known information management systems. Such sophisticated organization implies an advanced bureaucracy capable of coordinating taxation, diplomacy, international trade, agricultural production, and royal administration across a vast kingdom. The city itself reflects equally impressive planning. Streets connected administrative districts with workshops, warehouses, religious complexes, and residential neighborhoods through an organized urban network rather than random expansion. Massive defensive walls enclosed the settlement, while carefully engineered gateways controlled movement into the city. Constructing fortifications on terrain composed partly of earlier ruins presented enormous challenges because buried structures settle unevenly over time. The survival of significant portions of these defenses suggests that Ebla's builders understood how to stabilize foundations across artificially accumulated ground, although the exact techniques remain uncertain. Some archaeologists believe successive layers of compacted debris actually created remarkably stable building platforms, while others argue that extensive earthworks redistributed pressure beneath major monuments. The available evidence supports both possibilities without conclusively proving either. Perhaps even more intriguing is the enormous industrial effort required to create the city itself. Millions of standardized mud bricks would have been necessary to construct palaces, temples, defensive walls, warehouses, and private homes. Producing such quantities required consistent clay sources, abundant water, organized labor, standardized molds, drying areas covering vast surfaces, and careful logistical coordination. Yet surprisingly little direct evidence for brick manufacturing districts of comparable scale has been identified. The finished city clearly demonstrates industrial-level production, while much of the manufacturing process remains archaeologically invisible. This disconnect continues to puzzle researchers studying early urban economies throughout the ancient Near East. The repeated rebuilding of Ebla further strengthens the impression that later inhabitants deliberately reused the achievements of earlier generations instead of abandoning them. When buildings collapsed through earthquakes, warfare, or natural decay, the debris was rarely removed completely. Instead, it became the foundation for new construction. Each rebuilding phase inherited walls, terraces, drainage systems, and artificial platforms created centuries before, producing a city whose visible monuments represented only the latest layer in a much longer engineering tradition. By the time Royal Palace G reached its greatest splendor, countless forgotten structures already lay buried beneath its floors, silently supporting one of the most powerful kingdoms of the Bronze Age. The destruction of the palace around 2300 BC, commonly associated with campaigns linked to the Akkadian Empire, paradoxically ensured its preservation. Fire hardened thousands of clay tablets like ceramics inside a kiln, while collapsing walls sealed rooms beneath protective layers of debris. Later settlements rose above the ruins, unknowingly preserving them for over 4 millennia, until modern excavation revealed the city once again. Today, archaeologists continue to debate how much of Ebla's engineering knowledge disappeared forever with its destruction. No surviving text explains how its strongest bricks were manufactured, how multi-story mud brick buildings were designed to withstand immense weight, or how foundations remained stable atop centuries of accumulated ruins. On the Anatolian plateau, about 80 kilometers southwest of Ankara, lies a city that may not have been built on untouched ground at all. Beneath the capital of the ancient Phrygian kingdom, archaeologists uncovered layer after layer of earlier settlements, each buried beneath the remains of the last, creating a mound nearly 16 meters deep before the famous Iron Age city was even established. Rather than beginning from nothing, the builders of Gordian appear to have inherited the ruins of forgotten communities, reshaping them into one of the most sophisticated cities of the first millennium BC. The story emerged in 1950, when archaeologists from the University of Pennsylvania, led by Rodney Young, began systematic excavations at the large mound known as Yassıhöyük in central Turkey. What initially appeared to be a single ancient city gradually revealed itself as a sequence of occupations stretching back to the early Bronze Age, around 3000 BC. Excavation trenches exposed more than a dozen major construction phases, each separated by destruction layers, rebuilding episodes, and engineered terraces. Every generation had modified what the previous one left behind, transforming abandoned walls, collapsed buildings, and artificial platforms into the foundations of an entirely new city. Instead of clearing away the past, the inhabitants continuously built upward, creating an archaeological record that preserved nearly 2,000 years of uninterrupted urban development. That discovery fundamentally changed how researchers viewed Gordian. The legendary city associated with King Midas was no longer an isolated Iron Age capital, but the latest expression of a settlement whose roots extended deep into prehistory. Every palace, courtyard, and defensive wall rested upon structures that had already stood for centuries. The landscape itself became an engineered monument, shaped by countless generations who repeatedly adapted earlier architecture rather than replacing it completely. This raises an intriguing question that remains difficult to answer today. How much of the city's remarkable engineering actually belonged to the Phrygians, and how much represented inherited knowledge passed down from civilizations that had long disappeared? One of the strongest clues comes from the extraordinary preservation of the famous wooden burial chamber inside Tumulus MM, traditionally associated with the family of King Midas. Constructed around 740 to 700 BC, the massive burial mound rises approximately 53 meters high, with a diameter approaching 300 meters, making it one of the largest tumuli ever built in the ancient Near East. Hidden beneath hundreds of thousands of cubic meters of earth sits a timber chamber assembled from enormous cedar, juniper, and pine beams. Under ordinary conditions, wood buried underground gradually decomposes through fungi, bacteria, insects, moisture, and oxygen. Even exceptionally preserved wooden structures rarely survive beyond several centuries without major deterioration. Yet the chamber at Gordian has remained remarkably intact for nearly 3,000 years. Roof beams retain their original shape, tool marks carved by Iron Age axes remain visible, and complex timber joints still fit together with astonishing precision. Scientists have spent decades trying to explain this exceptional preservation. Laboratory studies suggest that the tightly compacted earth surrounding the chamber created an environment with extremely limited oxygen, dramatically slowing biological decay. The mound also maintained unusually stable temperature and humidity throughout the seasons, reducing the expansion and contraction that normally fractures ancient timber. Resin-rich conifer wood further resisted microbial attack, while the immense weight of the overlying soil prevented significant movement inside the chamber. Although each factor contributed, researchers still cannot fully explain why deterioration remained so minimal across the entire structure. Similar burial chambers elsewhere, built with comparable materials, experienced far greater damage despite apparently similar conditions. The combination of environmental control, construction technique, and material selection achieved at Gordian remains unmatched among Iron Age wooden monuments. This mystery becomes even more fascinating when considering how the chamber was actually constructed. Engineers estimate that the burial room measures roughly 5.15 meters long, 6.2 meters wide, and over 3 meters high. Massive horizontal timbers were carefully stacked in interlocking layers without metal reinforcement, capable of supporting modern structural loads. After the chamber was completed, workers buried it beneath an enormous artificial hill weighing hundreds of thousands of tons. Modern engineers understand how compressive forces behave under earth-filled structures, yet reconstructing the exact sequence used by the Phrygian builders remains challenging. If the mound had been filled too quickly, uneven pressure could have collapsed the roof. If the earth had not been compacted carefully, later settling would have crushed the chamber over time. Instead, the structure has survived almost intact despite earthquakes, seasonal climate cycles, and nearly 28 centuries of continuous pressure. Excavations throughout the settlement reveal that this sophisticated understanding of construction extended far beyond a single tomb. Large sections of Gordian's fortification walls incorporate massive stone foundations, supporting thick mud brick superstructures reinforced with carefully compacted earth. Instead of relying entirely on solid masonry, builders created composite defensive systems capable of absorbing movement and distributing stress more efficiently than rigid stone walls alone. Some surviving gateways display enormous limestone blocks, fitted together with surprising precision despite the absence of mortar. Their geometry suggests careful planning, standardized measurement, and advanced knowledge of structural balance rather than simple trial and error. The city itself also demonstrates an unusual level of urban planning. Streets align with organized building complexes, storage facilities occupy distinct sectors, and monumental administrative buildings dominate carefully arranged courtyards. Archaeologists have identified evidence of extensive grain storage, industrial production, textile manufacture, and long-distance trade. Such organization implies central planning, rather than gradual, uncoordinated expansion. Yet beneath these carefully planned districts lie earlier architectural phases with similar orientations, suggesting that successive generations repeatedly reused ancient foundations instead of abandoning them. This continuity raises the possibility that practical engineering knowledge survived political collapse, passed quietly from builders to apprentices across centuries even as kingdoms rose and disappeared. One of the most debated events in Gordian's history further complicates the story. Around the late 8th century BC, much of the city experienced a catastrophic fire. Burned mud brick, collapsed roofs, and thick charcoal deposits appear across major excavation areas. For many years, this destruction was attributed to the invasion of the Cimmerians, nomadic groups recorded in ancient historical sources. More recent dating techniques, however, indicate that the fire may have occurred earlier than previously believed, forcing historians to reconsider one of Anatolia's most famous historical narratives. Whether caused by warfare, accidental disaster, or internal conflict, the destruction buried entire neighborhoods beneath protective layers of debris. Ironically, that catastrophe preserved countless details of daily life, allowing archaeologists to reconstruct construction methods with remarkable accuracy thousands of years later. Today, Gordian is a layered archive of nearly 3 millennia of human engineering. Excavations reveal successive cities built on older foundations, showing accumulated knowledge rather than isolated innovation. From the preserved wooden chamber to its defensive walls and urban plan, the site suggests that much practical engineering was inherited and later lost with the civilizations that created it. On the edge of Iran's Sistan Basin, near the border with Afghanistan, lies Shari Sokhta, the Burnt City, a Bronze Age metropolis that flourished between roughly 3200 and 1800 BC. Excavations have revealed a settlement covering more than 150 hectares, with an estimated population approaching 10,000 people, making it one of the largest urban centers of its age. Yet what has puzzled archaeologists for decades is not simply its size, but the unsettling impression that its inhabitants possessed knowledge that seems to appear fully formed, as though inherited from an earlier world whose identity has long vanished. Rather than evolving gradually from scattered villages, Shari Sokhta emerges in the archaeological record with advanced craftsmanship, organized industry, long-distance trade, and medical practices that appear centuries ahead of surrounding cultures. The site remained buried beneath desert sediments until the early 20th century, when British explorer Aurel Stein documented its enormous mounds. Systematic excavations led by Italian archaeologist Maurizio Tosi beginning in 1967 uncovered thousands of graves, workshops, streets, and residential districts, transforming what had once appeared to be little more than barren earth into evidence of one of the most sophisticated Bronze Age cities ever discovered. Yet, every excavation answered one question only to raise several more, because the deeper researchers explored, the more they encountered technologies that seemed strangely disconnected from what was believed possible nearly 5,000 years ago. Among all discoveries at Shari Sokhta, none has challenged conventional expectations more than the artificial eye found inside the grave of a young woman estimated to have died between 25 and 30 years old. Radiocarbon dating places the burial at approximately 2900 to 2800 BC, making this the oldest known ocular prosthesis ever discovered. The eye was carefully crafted from a lightweight mixture believed to contain natural bitumen combined with organic materials, while its surface carried an impossibly thin layer of gold. Fine engraved lines radiated across the surface to imitate blood vessels, and the central pupil was formed with remarkable geometric precision. Tiny perforations on either side allowed the prosthesis to be secured with delicate threads, indicating that it had been worn during the woman's lifetime rather than created solely for burial. Microscopic examination even revealed traces of prolonged contact between the artificial eye and surrounding tissue, suggesting years of continuous use. The achievement raises a question that remains unanswered today. How did Bronze Age craftsmen understand anatomy, optics, material engineering, and miniature manufacturing well enough to produce a prosthetic device sophisticated enough to fit comfortably inside a living human eye? No surviving workshop, written manual, or contemporary description explains the techniques involved, leaving researchers to reconstruct an entire technological tradition from a single extraordinary artifact. That discovery becomes even more astonishing when viewed alongside evidence of advanced medicine elsewhere in the city. One adolescent girl's skull bears unmistakable signs of cranial surgery, in which part of the skull was deliberately removed, probably to relieve pressure caused by hydrocephalus. More remarkable still, the surrounding bone regenerated after the operation, demonstrating that the patient survived for months following the procedure. Successful cranial surgery requires far more than courage. It demands anatomical knowledge, precise cutting tools, methods for controlling bleeding, and some understanding of infection. Yet none of these supporting technologies have been identified with certainty. Copper instruments alone struggle to explain the clean surgical precision visible on the skull, leaving specialists uncertain about exactly how the operation was performed. The same pattern appears throughout the city's industries. Workshops produced thousands of beads from lapis lazuli, turquoise, carnelian, and other exceptionally hard stones imported from regions hundreds or even thousands of kilometers away. Many contain drill holes barely a millimeter across that remain astonishingly straight throughout their length. Experimental archaeologists have attempted to recreate these perforations using Bronze Age tools, abrasive sands, and bow drills, but reproducing the consistency achieved at Shari Sokhta remains both slow and technically demanding. Whatever manufacturing methods these craftsmen mastered allowed them to produce ornaments on a scale approaching specialized industry rather than occasional artisan work. Their command of materials extended well beyond stone. Excavations uncovered evidence for early glass production, faience technology, carefully controlled ceramic firing, and composite substances whose exact recipes remain uncertain. Some finished surfaces retain their color and polish after nearly 5 millennia, despite prolonged burial beneath shifting desert sediments. Researchers continue to analyze mineral compositions and firing temperatures, yet the complete technological sequence behind these durable materials has not been fully reconstructed. It is difficult to avoid the impression that generations of accumulated experimentation existed long before the city reached its archaeological peak. This impression becomes stronger when examining the city's urban organization. Residential neighborhoods, workshops, cemeteries, industrial zones, and storage areas were arranged with surprising order across the settlement. Drainage systems, carefully planned streets, and specialized production districts indicate centralized planning sustained over many centuries. Yet unlike Egypt or Mesopotamia, Shari Sokhta has yielded no monumental palaces, royal inscriptions, or massive temples celebrating powerful kings. The administrative mechanism capable of coordinating such a large population remains largely invisible, creating the paradox of a remarkably organized city with surprisingly little evidence of the political machinery usually associated with complex urban societies. Its commercial connections stretched across an equally remarkable landscape. Lapis lazuli arrived from Badakhshan in present-day Afghanistan, shells traveled from the Arabian Sea, copper likely came from Oman, while similarities in artifacts reveal sustained contact with the Indus civilization and Mesopotamia. Maintaining exchange networks over thousands of kilometers required logistical planning, reliable transportation, and stable economic relationships. Yet the organizational framework supporting this immense trade system remains poorly understood. The city appears not as an isolated settlement, but as one of the major hubs within an international world whose full structure has yet to be reconstructed. One small artifact captures the intellectual sophistication of its inhabitants in an entirely different way. A painted ceramic vessel, decorated with sequential images of a goat reaching toward a tree, creates the illusion of motion when rotated, making it one of the earliest known examples of animated imagery in human history. An artist clearly understood that rapidly viewed sequential images could create perceived movement, a concept usually associated with inventions thousands of years later. Whether this represented entertainment, ritual symbolism, or something entirely different remains uncertain, but it demonstrates an awareness of visual perception that feels strikingly modern. Perhaps the greatest mystery, however, is not how Shari Sokhta flourished, but why it disappeared. Archaeological evidence reveals multiple destructive fires over several centuries, giving the settlement its modern name. Yet no single catastrophe explains its decline. Instead, environmental change appears to have played a significant role as the Helmand River altered its course, gradually undermining the agricultural foundation upon which the city depended. Even so, the disappearance of such a sophisticated center left surprisingly little cultural continuity behind. Many of its technologies seem to fade rather than spread, as though fragments of accumulated knowledge were extinguished together with the civilization that preserved them. Kultepe, ancient Kanesh in central Turkey, was built and rebuilt for nearly 2,000 years, preserving the remains of forgotten cities beneath every new generation of walls, until one of the oldest commercial capitals of the Bronze Age emerged above foundations laid by people whose names had already disappeared from history. The significance of the site only became clear after systematic excavations began in 1948 under Turkish archaeologist Tahsin Özgüç. Although cuneiform tablets had first appeared on the antiquities market decades earlier, archaeologists eventually uncovered more than 23,000 clay tablets, together with multiple occupation layers dating from the early Bronze Age to the early 2nd millennium BCE. Instead of revealing a single city frozen in time, the excavations exposed an enormous archaeological mound composed of successive settlements, each constructed directly over the ruins of those that had come before. Every rebuilding episode buried streets, houses, workshops, and public buildings beneath new foundations, transforming Kanesh into one of the clearest examples of an ancient place literally built upon earlier worlds. This layered history immediately raises an intriguing question. The famous Assyrian merchant colony that flourished around 1900 to 1700 BCE appears remarkably sophisticated, yet almost every achievement rested upon engineering inherited from centuries of previous occupation. Long before Assyrian traders established their commercial district, generations of builders had already reshaped the landscape through artificial terraces, leveled platforms, and carefully compacted construction layers. Rather than beginning from untouched ground, the city's greatest period depended upon accumulated knowledge preserved invisibly beneath its own streets. That continuity becomes even more remarkable when examining the city's urban organization. Excavations reveal neighborhoods that repeatedly occupied nearly identical locations despite fires, destruction, and rebuilding. Walls often followed the same alignments established centuries earlier, while streets remained surprisingly consistent through multiple construction phases. Such continuity suggests that later inhabitants understood the advantages of earlier planning instead of abandoning it. Every reconstruction effectively recycled the work of forgotten predecessors, allowing practical engineering decisions made generations earlier to influence the city long after their creators had vanished. Among the greatest unresolved mysteries surrounding Kanesh lies the question of tin, the essential ingredient required to transform copper into bronze. Bronze tools, weapons, and agricultural equipment depended on an alloy containing roughly 8 to 12% tin, yet central Anatolia possessed no major known tin deposits capable of sustaining such enormous production. Nevertheless, the cuneiform archives describe an exceptionally organized trade in tin, arriving regularly from distant regions. Merchants carefully recorded shipments, weights, taxes, partnerships, transportation costs, and profits with astonishing precision, demonstrating that the supply operated reliably over decades rather than through occasional exchanges. The problem is that archaeologists still cannot identify with certainty where much of this tin originated. Various scientific studies have proposed sources in Central Asia, the Iranian Plateau, Afghanistan, or smaller Anatolian deposits, while isotopic analyses have produced conflicting results that fail to establish one definitive origin. If the larger eastern sources supplied Ganesh, merchants would have transported valuable cargo across well over 1,000 kilometers of mountains, deserts, and politically fragmented territories long before organized empires controlled these routes. Such logistics rival some of the most sophisticated commercial networks of the ancient world, yet almost none of the infrastructure supporting this immense supply chain has survived. Warehouses large enough to manage constant imports remain elusive, caravan stations are poorly understood, and no complete route has been reconstructed despite decades of archaeological investigation. This mystery becomes even more striking because the city's economy functioned with extraordinary consistency. Thousands of tablets reveal standardized measurements, carefully calculated loans, legal contracts, and detailed accounting records showing surprisingly few discrepancies. Such accuracy implies the existence of reliable systems for weighing metals and verifying transactions across enormous distances. Stone weights have been discovered, but the broader mechanisms ensuring identical standards between distant trading centers remain largely unknown. Maintaining commercial confidence across hundreds of merchants would have required remarkable administrative discipline, yet the practical technology supporting that discipline has largely disappeared, leaving behind only written evidence that it once existed. As the city expanded, builders continued relying upon foundations created centuries before. Excavation profiles reveal repeated cycles in which collapsed mud brick architecture was not removed entirely, but compacted into stable construction platforms, supporting new buildings above. Each rebuilding phase raised the ground level slightly higher, producing the tell visible today. This method reduced labor, while simultaneously strengthening the urban landscape, allowing later generations to inherit increasingly elevated and stable foundations. Modern archaeology demonstrates that many impressive structures traditionally associated with the Assyrian trading period actually rested upon buried engineering accumulated over hundreds of years of continuous occupation. The remarkable resilience of these construction methods presents another unanswered technological question. Mud brick is often considered fragile, yet substantial architectural remains survived nearly 4,000 years because ancient builders carefully controlled soil composition, moisture, straw temper, drainage, and foundation preparation. Repeated rebuilding also created thicker occupation layers that distributed structural loads more evenly across the mound. Although experimental archaeology has reproduced individual mud brick techniques, researchers still cannot fully explain how entire urban districts maintained such long-term stability through repeated earthquakes, fires, seasonal flooding, and continuous human occupation. The famous merchant quarter, known as the Karam, also illustrates how invisible earlier engineering shaped later prosperity. Houses were organized into orderly blocks, separated by narrow streets, many containing storage rooms, archives, workshops, and upper floors. Yet beneath these carefully planned neighborhoods lay older settlements whose buried walls and compacted debris had already transformed uneven terrain into buildable platforms. Instead of erasing the past, every generation unknowingly depended upon it. The city literally expanded by standing on forgotten architecture whose original purpose had long been lost. Even the extraordinary archive itself reflects technological knowledge that remains only partially understood. More than 23,000 clay tablets survived because scribes selected suitable clay, prepared consistent writing surfaces, and stored documents in conditions that frequently allowed accidental firing during destructive fires. Rather than destroying the archives, intense heat often baked the clay permanently, preserving contracts, letters, inventories, and legal records for almost 4 millennia. Archaeologists can now reconstruct commercial life with remarkable detail. Yet the practical techniques governing the preparation, storage, and preservation of such massive documentary collections remain incompletely understood because most of the supporting infrastructure disappeared with the city. Repeated destruction never marked the true end of Kanesh. Fires devastated neighborhoods, political circumstances shifted, and commercial influence gradually declined, but rebuilding continued upon the same accumulated mound. Each new generation inherited stabilized ground, buried foundations, and urban layouts established by predecessors they may scarcely have remembered. Over centuries, the city became an archaeological archive in which every occupation concealed another beneath it, preserving evidence not only of changing civilizations, but also of engineering traditions transmitted through construction itself, rather than through surviving written manuals. Zincirli Höyük, Samal, southeastern Turkey. Beneath the circular walls of this Iron Age capital lies the accumulated legacy of older settlements, where every generation built upon the remains of those before it, preserving fragments of engineering knowledge that survived long after the people who created it disappeared. The first scientific excavations at Zincirli Höyük began in 1888. Under the German Oriental Society, after monumental basalt sculptures and inscriptions attracted international attention, archaeologists soon realized they were not uncovering a single city, but a settlement mound nearly 30 meters high, created by thousands of years of continuous occupation. Excavations revealed successive architectural layers stretching from the early Bronze Age through the Iron Age, culminating in the Aramaean kingdom of Samal between the 10th and 8th centuries BCE. Every excavation trench exposed an older city beneath a later one, showing that the famous capital had inherited foundations laid centuries before rather than rising on untouched ground. This long sequence of rebuilding makes Zincirli Höyük one of the clearest examples of an ancient place constructed upon earlier worlds. Yet its greatest mystery begins with the city itself. Seen from above, Samal appears remarkably geometric. The fortified city forms an almost perfect circle, measuring roughly 720 meters in diameter, enclosed by massive defensive walls interrupted by carefully positioned gates and towers. Creating such regular geometry across uneven terrain would have required accurate surveying over distances exceeding 2 kilometers around the entire perimeter. The kingdom flourished before advanced iron engineering became widespread across the region, yet no instruments capable of producing such precision have ever been recovered from the site. Archaeologists know the walls were carefully planned, but exactly how surveyors maintained a nearly constant radius while adapting to natural variations in the landscape remains uncertain. The more accurately the city's geometry is mapped with modern equipment, the more deliberate its design appears, suggesting that practical knowledge of large-scale measurement was considerably more sophisticated than the surviving tools alone would indicate. That precision becomes even more intriguing because the circular fortress was not created in isolation. Excavation beneath the defensive system shows that later builders repeatedly incorporated earlier occupation layers instead of removing them. Rather than leveling the mound completely before construction, they transformed older buildings, collapsed walls, and accumulated debris into stable platforms supporting new fortifications above. This process gradually raised the entire settlement while preserving hidden sections of previous cities underneath. Every rebuilding phase therefore inherited an increasingly elevated artificial landscape whose structural behavior had already been tested through generations of occupation. The visible Iron Age capital was only the newest layer, resting upon centuries of forgotten engineering. The enormous basalt architecture surrounding the gates presents another unanswered question. Monumental lion sculptures, sphinxes, and orthostat slabs weighing many tons guarded the entrances to the city and royal palace. Basalt is significantly harder than the limestone commonly used throughout much of the ancient Near East, requiring extensive shaping before transport and installation. Yet nearby outcrops capable of supplying all of these finished blocks are limited, meaning large stones had to be quarried elsewhere and moved considerable distances. Scholars propose combinations of wooden sledges, rollers, ropes, and animal traction, but no archaeological evidence preserves the exact transport system. Equally uncertain is how workers maneuvered these heavy monuments into precise positions along gateways where adjoining blocks align with remarkable consistency. Once installed, those basalt slabs reveal another technical puzzle. The carved reliefs often continue seamlessly from one stone to the next, creating uninterrupted processions of rulers, warriors, deities, and animals across multiple orthostats. If every slab was carved before installation, craftsmen would have needed exact knowledge of the final position of each block long before construction ended. If carving took place after installation, sculptors would have been required to work on vertical surfaces while maintaining continuous proportions across joints, separating individual stones. Neither approach has been confirmed archaeologically, and no workshop has been discovered preserving unfinished examples that explain the sequence of production. The survival of the city itself raises additional questions about structural engineering. Southeastern Turkey lies within a region affected by repeated seismic activity, yet substantial sections of Samal's fortifications remained standing for nearly 3,000 years. Excavations show that the foundations were not simply built upon exposed bedrock. Builders frequently combined stone courses with carefully compacted layers of soil, gravel, and earlier occupation debris beneath the walls. Some engineers studying these foundations have suggested that the alternating materials may have helped distribute stress during ground movement, functioning as a primitive form of seismic stabilization. Whether this arrangement resulted from deliberate understanding or generations of practical observation remains impossible to determine, but its effectiveness is demonstrated by the remarkable longevity of the surviving structures. The city's hydraulic system introduces another unresolved aspect of its engineering. Archaeologists have uncovered stone-lined drains, underground channels, and carefully planned water routes passing beneath courtyards and buildings. Several channels, however, terminate unexpectedly or fail to connect with obvious outlets beyond the walls. Others appear too carefully constructed to have served only temporary drainage. It remains unclear whether these passages formed part of a larger network now destroyed, supported wooden superstructures that have vanished, or combined practical water management with ceremonial functions no longer recognizable from the surviving remains. Because later rebuilding repeatedly altered the city's layout, reconstructing the original hydraulic system has proven exceptionally difficult. Measurements taken throughout the palace complex reveal striking architectural regularity. Courtyards, reception halls, column spacing, and room dimensions frequently repeat according to consistent intervals, implying that builders worked from standardized units rather than relying solely on visual estimation. This suggests the existence of an organized system of measurement shared among architects and craftsmen. Yet, despite thousands of artifacts recovered from Zincirli Höyük, No measuring rods or written technical manuals have been found explaining the standards that governed construction. The buildings themselves preserve the evidence of careful planning, while the knowledge that produced them has disappeared almost entirely. Even the decorative stonework demonstrates craftsmanship that continues to provoke debate. Basalt is an exceptionally dense volcanic rock, capable of resisting weathering for millennia, but it is also notoriously difficult to carve with simple tools. Nevertheless, reliefs from Samal display sharp outlines, smooth curves, uniform inscriptions, and finely finished surfaces. Experimental archaeology has shown that abrasive sands, hammerstones, and early iron tools can reproduce some of these features, yet the efficiency required to decorate an entire royal capital remains difficult to explain. No complete sculptor's workshop has been excavated, leaving the exact manufacturing process largely hidden beneath centuries of lost practice. Perhaps the most remarkable aspect of Zincirli Höyük is how every generation treated the achievements of its predecessors. Buildings damaged by time, warfare, or natural disaster were rarely removed completely. Instead, collapsed walls became terraces, abandoned rooms became compacted foundations, and earlier streets disappeared beneath new avenues that followed many of the same alignments. Layer after layer, forgotten cities continued supporting the lives of later inhabitants, who often built directly above structures they could no longer fully see. By the time the Kingdom of Samal reached its greatest prosperity, much of its engineering depended upon foundations created centuries earlier by people whose names had already vanished from memory. Located on the modern plains of Malatya, eastern Turkey, Arslantepe is not simply an ancient settlement. Rising nearly 30 meters above the surrounding landscape, this mound preserves over 6 millennia of continuous occupation, where one civilization repeatedly buried the remains of another until an entire artificial hill emerged from forgotten cities stacked beneath later generations. Its scientific discovery began in the late 19th century, but systematic excavations by Italian archaeologists from Sapienza University of Rome, continuing from 1961 onward, revealed that the mound contained an extraordinary sequence of occupation stretching from roughly 5000 BC to the Byzantine period. Layer after layer exposed palaces, temples, houses, workshops, and fortifications constructed directly upon earlier ruins instead of clearing them away. Every rebuilding phase transformed collapsed architecture into foundations for new construction, making Arslantepe not one city, but an accumulated record of thousands of years of engineering, inherited, modified, and sometimes forgotten. Among the most remarkable discoveries are the traces of interior decoration that still survive after more than 5,000 years, challenging expectations about the durability of prehistoric building materials. Inside the monumental palace, dating to approximately 3000 BC, archaeologists uncovered walls still bearing vivid bands of red, black, and white pigments applied across carefully prepared mud plaster surfaces. These were not random stains left by minerals, but deliberate decorative programs covering ceremonial halls and administrative corridors. The remarkable preservation raises difficult technical questions because mud plaster normally erodes rapidly under humidity, salt crystallization, and repeated seasonal expansion. Yet these pigments remained bonded to their surfaces for millennia. Microscopic analyses have identified mineral-based colorants such as iron oxides for red and carbon-rich compounds for black, but the precise preparation of the plaster, the composition of binding agents, and the application techniques remain incompletely understood. Whether ancient builders employed organic additives, multiple plaster layers, or specialized burnishing methods capable of dramatically extending durability continues to be debated. Modern conservation can explain part of their survival, but it cannot fully explain why these painted interiors endured long enough to reach archaeologists in such recognizable condition. That remarkable preservation becomes even more significant because the decorated palace itself was never intended to stand alone. Excavation shows that its floors rested upon earlier construction phases, while later inhabitants eventually built directly over its abandoned walls. Rather than removing collapsed buildings, generations repeatedly leveled damaged structures, filled rooms with debris, and constructed new monuments on top. This process gradually elevated the settlement into a massive archaeological mound. Every new palace inherited foundations created centuries earlier, meaning that rulers often governed from buildings physically supported by forgotten architecture whose original builders had disappeared long before. The visible city was therefore only the latest chapter, resting upon invisible engineering created by previous societies. This pattern of continuous rebuilding also explains why Arslan Tepe represents one of the earliest examples of centralized government emerging from accumulated architectural history instead of appearing suddenly on untouched ground. 3300 BC. A monumental palace complex covering roughly 4,500 square meters dominated the summit. It contained reception halls, storage facilities, administrative rooms, controlled entrances, and ceremonial spaces connected through carefully planned corridors. The layout directed movement with remarkable precision, separating officials, workers, visitors, and stored goods into distinct functional areas. Such organization resembles later state administrations across Mesopotamia, yet Arslan Tepe developed its own distinctive system while constantly incorporating structural remains inherited from previous occupations. Ancient architects were therefore designing sophisticated public buildings while simultaneously adapting to foundations that had already existed for generations. The engineering challenge becomes even greater, considering that almost every monumental structure was constructed primarily from sun-dried mud brick rather than stone. Thousands of bricks had to maintain uniform dimensions, consistent moisture content, and controlled drying rates to avoid catastrophic cracking. The walls remained stable despite repeated earthquakes common throughout eastern Anatolia, suggesting that builders possessed extensive practical knowledge of soil composition, fiber reinforcement, and load distribution. Archaeologists can analyze surviving bricks and identify mixtures of clay, silt, sand, and organic temper. Yet no surviving documents explain how ancient builders determined the precise proportions required to create structures capable of surviving thousands of years beneath successive cities. The durability of these earthen buildings demonstrates an engineering tradition far more sophisticated than their simple appearance suggests. As excavations continued through the palace, another technological mystery emerged from a cache of ceremonial weapons unlike anything previously known. Dating to approximately 3,300 BC. Several long blades discovered within the complex are widely regarded as some of the earliest true swords ever identified. Unlike shorter daggers, these weapons possessed lengths approaching 60 centimeters and were manufactured using arsenical copper, an alloy significantly harder than pure copper. Producing such metal required selecting ores naturally containing arsenic or intentionally combining different mineral sources under carefully controlled smelting conditions. Both possibilities demand practical metallurgical knowledge well beyond simple copper casting. even more remarkable, heating arsenic-bearing ores releases toxic fumes dangerous to anyone working nearby. Whether ancient metalworkers intentionally mastered this alloy or accidentally discovered its superior mechanical properties remains uncertain, because no complete metallurgical workshops have yet been identified to explain the production process. The palace economy reveals another unexpected level of technological sophistication through thousands of clay ceilings recovered from storage rooms and entrances. Before widespread writing became common in the region, administrators controlled access to goods by pressing uniquely carved seals into lumps of wet clay attached to doors, containers, and bundles. Breaking a seal immediately exposed unauthorized access, creating an efficient administrative security system. Hundreds of different seal impressions demonstrate an organized bureaucracy managing food supplies, valuable materials, and official transactions long before alphabetic records existed. The system depended not only on artistic craftsmanship, but also on standardized procedures understood across the administrative hierarchy, suggesting that information management evolved alongside monumental architecture. Yet perhaps the most intriguing aspect of Arslan Tepe is how repeatedly rebuilding upon earlier ruins gradually obscured the technological achievements of previous generations. Each reconstruction buried flaws beneath new platforms, concealed drainage systems inside fresh walls, and transformed abandoned ceremonial spaces into structural foundations supporting later buildings. Over centuries, practical engineering knowledge may have been inherited directly through construction itself rather than written instruction, with builders learning from existing structures even after their original creators had vanished. As occupations changed and political systems evolved, some techniques survived while others disappeared, leaving archaeology to reconstruct only fragments of a once continuous tradition. This long sequence of destruction followed by renewal distinguishes Arslan Tepe from monuments built in a single grand episode. The site demonstrates that civilizations often advanced not by abandoning the past but by literally standing upon it. Every palace incorporated buried architecture. Every administrative center concealed forgotten settlements beneath its floors. And every generation unknowingly depended upon engineering solutions developed centuries before. What appears today as a single archaeological mound is therefore the accumulated product of repeated human attempts to preserve authority, technology, and architecture through continuous rebuilding. Godin Tepe, Kangavar Valley, Western Iran. Hidden beneath a quiet mound rising above an ancient trade corridor lies a settlement that may preserve the remains of civilizations built one upon another for nearly 5,000 years. Every major occupation reshaped the ruins left by its predecessors, instead of starting from untouched ground, creating a layered archaeological record that has led some researchers to describe Godin Tepe as a place where each new world inherited the foundations of an older one. Yet among all its discoveries, one mystery stands above the rest. Evidence suggesting that industrial-scale production of beer and wine was already taking place more than 5,000 years ago, centuries before the rise of the great empires normally credited with organizing such complex economies. The site first attracted archaeological attention during surveys of Western Iran in the 1960s, but systematic excavations directed by Canadian archaeologists from the Royal Ontario Museum, beginning in 1965, revealed something far more extraordinary than expected. Instead of a single settlement, archaeologists uncovered a sequence of at least 7 major occupation levels spanning roughly from around 5000 BC to the first millennium BC. Each generation repeatedly cut into, leveled, and rebuilt over older structures, leaving thick cultural deposits several meters deep. Walls rested on collapsed buildings, new storage rooms replaced earlier workshops, and later administrative complexes stood directly above settlements that had disappeared centuries before. The result was not simply one ancient city, but an architectural timeline preserving thousands of years of technological evolution within the same hill. That continuous rebuilding immediately raised an important question. Why would communities repeatedly choose exactly the same location, despite wars, environmental changes, and political collapse? Geography offers only part of the answer. Godin Tepe occupies a strategic position along the Kangavar Valley, connecting Mesopotamia with the Iranian Plateau and ultimately Central Asia. Long before formal highways existed, this corridor linked some of the most economically important regions of the ancient Near East. Every civilization occupying the site inherited not only buildings buried beneath its feet, but also access to one of the oldest commercial routes in Western Asia, making the mound itself an asset worth rebuilding again and again. The greatest mystery emerged inside large storage buildings dating to approximately 3500 to 3000 BC. Archaeologists discovered rows of massive ceramic jars, unlike ordinary household containers. Chemical analyses identified residues of calcium oxalate, often called beer stone, together with tartaric acid and related compounds associated with grape wine. Either discovery alone would have been significant, but their archaeological context transformed them into something far more remarkable. These vessels were not scattered randomly throughout domestic houses. They were concentrated within organized storage areas, positioned in ways suggesting controlled handling rather than casual family consumption. Many jars shared remarkably similar dimensions, implying standardized production instead of individual craftsmanship. Together they formed compelling evidence that Godin Tepe may have operated what was effectively an industrial food and beverage facility more than 5,000 years ago. This interpretation immediately introduces technological questions that remain unanswered today. Brewing and winemaking at such a scale require more than simply fermenting grain or grapes. Temperatures must remain reasonably stable, contamination must be minimized, storage vessels must be sealed effectively, and production batches must remain consistent enough for large quantities to retain predictable quality. No written manuals survive explaining how these ancient workers controlled fermentation, maintained yeast cultures, or organized production across dozens of enormous containers. Modern experimental archaeology has reproduced ancient brewing methods on a small scale, yet the logistical sophistication implied at Godin Tepe remains only partially understood. The technology itself may not have relied upon metal machinery, but it certainly depended upon knowledge systems whose details disappeared thousands of years ago. As researchers continued excavating deeper levels, another puzzle emerged from the architecture surrounding these storage facilities. The buildings were carefully planned rather than expanding randomly over time. Rooms appear to have served different functions, including storage, administration, processing, and controlled access. Such specialization resembles an organized economic center more than a typical prehistoric village. Some archaeologists have compared the layout to an administrative warehouse where commodities were received, recorded, stored, and redistributed. If that interpretation is correct, Godin Tepe represents one of the earliest examples of institutional management surviving anywhere in the ancient world. Supporting this possibility are hundreds of clay ceilings discovered throughout the site. Before writing became widespread, officials often secured containers, storerooms, or doors using lumps of wet clay impressed with carved stone seals. Breaking the seal revealed unauthorized access. At Godin Tepe, many of these seal impressions display exceptionally detailed geometric and animal designs, requiring astonishing precision to engrave onto extremely hard stone surfaces. Even today, reproducing such intricate microscopic carvings without magnification demands remarkable craftsmanship. Archaeologists still debate the exact drilling and engraving techniques employed by seal makers because the finest grooves seem disproportionately precise compared with the simple bronze tools generally associated with the period. The existence of standardized containers, administrative architecture, and sealing technology suggests another forgotten innovation: measurement. Many storage jars appear surprisingly uniform in volume despite being handmade. Standard capacities would have simplified taxation, trade, and ration distribution, yet no surviving measuring system explains how potters repeatedly achieved such consistency. Whether fixed wooden gauges, calibrated cords, or carefully maintained master vessels existed remains unknown. Nevertheless, the archaeological evidence strongly implies that some standardized system operated behind the scenes, invisible except through the products it left behind. Godin Tepe becomes even more intriguing when viewed within the wider commercial world of the 4th millennium BC. Excavations recovered materials whose geological origins lie hundreds or even thousands of kilometers away. Lapis lazuli reached the settlement from mines in present-day Afghanistan. Bitumen likely arrived from Mesopotamia. Metals and other valuable materials traveled across mountain ranges long before imperial road systems existed. Such exchanges reveal supply networks extending well beyond local communities. Yet historians still cannot fully explain how merchants coordinated movement across these enormous distances without centralized states controlling every stage of transportation. Godin Tepe may have functioned as an important redistribution center connecting independent trading societies, but the mechanisms governing that network remain largely invisible. One of the most debated chapters in the site's history concerns its relationship with the famous Uruk civilization of southern Mesopotamia. Certain architectural styles, ceramics, administrative practices, and seal designs closely resemble those found in Uruk settlements hundreds of kilometers away. Some scholars argue that Godin Tepe was an Uruk trading colony, established to secure valuable resources. Others believe local communities simply adopted foreign technologies while remaining politically independent. Neither explanation fully accounts for every archaeological discovery. Instead, the evidence suggests a far more complex interaction in which ideas, technologies, and economic practices moved across cultural boundaries without necessarily requiring military conquest or direct political control. Equally mysterious are the repeated cycles of abandonment and renewal visible throughout the mound. Entire occupation levels ended, new populations arrived generations later, and fresh buildings rose directly above forgotten ruins. In many cases, archaeologists found no evidence of catastrophic warfare or massive destruction capable of explaining these transitions. Climate fluctuations, changing trade routes, political instability, or gradual economic decline have all been proposed, yet none fully explains why the location repeatedly lost and regained importance across thousands of years. Every rebuilding episode effectively buried another civilization beneath the next, preserving a vertical archive of human adaptation unlike almost anywhere else in Western Iran. Southern Anatolia, near the Goksu River in modern-day Kilise Tepe, holds a settlement that should not have survived as long as it did. Built largely from mud brick, exposed to earthquakes, seasonal flooding, and the collapse of entire Bronze Age kingdoms, Kilise Tepe endured for nearly 2,000 years. But the deeper archaeologists excavated, the stranger the site became. Beneath its ruined walls were signs of advanced storage engineering, climate control systems, shock-resistant construction, and food preservation methods that still remain only partially understood. The site was first surveyed in the 1950s during explorations connected to the Goksu Valley, but major excavations began decades later under teams associated with Cambridge University and the British Institute at Ankara. Archaeologists expected a modest provincial settlement. Instead, they uncovered evidence suggesting Kilise Tepe functioned as a strategically important node between the Hittite world of central Anatolia and Mediterranean trade routes. What shocked researchers most was not wealth or monumental architecture, but the technological sophistication hidden inside apparently simple mud brick structures. One of the earliest mysteries involved the settlement's architecture itself. Mud brick was one of the most fragile construction materials of the ancient world. In regions with heavy rainfall, buildings made from sun-dried clay could erode within decades, if not constantly maintained. Yet parts of Kilise Tepe survived in recognizable form after more than 3 millennia. Excavations revealed that the builders did not rely on ordinary clay alone. The bricks contained carefully balanced mixtures of straw, gravel, ash, and compacted sediment layers beneath the foundations. Some walls even showed microscopic gaps that may have allowed controlled flexing during seismic activity. This has led some researchers to compare Kilise Tepe's engineering principles to later earthquake-resistant methods found in Hittite and even Roman frontier settlements. Anatolia sits near several tectonic fault systems, and ancient communities regularly faced earthquakes. At sites like Troy and Hattusa, evidence shows repeated rebuilding after seismic destruction. But Kilise Tepe appears to have incorporated preventative structural techniques rather than simply rebuilding after collapse. The city's environmental control systems are equally mysterious. Southern Anatolia experiences intense summer heat, with temperatures often exceeding 35 degrees Celsius, while winters can bring cold rain and damp air flowing inland from the Mediterranean. Yet many storage rooms at Kilise Tepe maintained remarkably stable internal conditions. Archaeologists discovered raised floors, ventilation gaps beneath storage areas, unusually thick insulated walls, and courtyard layouts designed to channel airflow through narrow passages. These features created what modern engineers would call passive climate control. Similar principles appear in Persian wind catchers and later Islamic desert architecture, but Kilise Tepe predates many of these systems by centuries. Thermal modeling suggests some interior spaces may have remained significantly cooler than outside temperatures during summer months. This would have been critical for grain preservation in an era without refrigeration. But the greatest mystery of Kilise Tepe centers on its enormous storage complexes and the unexplained efficiency of its food management systems. Excavators uncovered massive silo areas capable of storing huge quantities of grain, likely barley and wheat. Some estimates suggest the site may have held enough reserves to support not only its own population, but travelers, caravans, or regional redistribution networks. In Bronze Age societies, food storage was power. Grain controlled labor, trade, survival during droughts, and military logistics. Entire kingdoms rose or collapsed depending on harvestability. What makes Kilise Tepe extraordinary is the sophistication of its preservation systems. Ancient grain storage usually faced 4 major threats: moisture, insects, fungal contamination, and temperature fluctuations. Even small increases in humidity could destroy reserves within months. Yet archaeologists found evidence that many Kilise Tepe storage chambers remained unusually dry and stable. Some silo interiors contained hardened clay linings that appeared intentionally heat-treated. Researchers believe controlled firing may have partially vitrified the inner surfaces, creating a barrier against moisture and microorganisms. In modern terms, the effect resembles ceramic sealing technology. Similar methods were not commonly associated with rural Anatolian settlements of this period. The floors beneath certain storage rooms also contained layered gravel and compacted earth, designed to improve drainage and prevent rising groundwater from reaching the grain above. Some chambers appear to have used airflow channels that allowed warm air to escape while cooler air circulated below the stored crops. This passive ventilation system reduced condensation, one of the most dangerous threats to long-term food storage. The sophistication becomes even more disturbing when compared with other Bronze Age civilizations. In many parts of the Eastern Mediterranean during the late Bronze Age collapse around 1200 BCE, centralized food systems failed catastrophically. Major powers, including the Hittites and Mycenaeans, experienced famine, warfare, and economic breakdown. Trade routes disintegrated, entire cities burned. Yet Kilisa Tepe appears to have continued operating through at least part of this collapse period. That raises a dangerous question for archaeologists. Did smaller regional centers like Kilisa Tepe possess survival strategies more resilient than those of the great empires themselves? Some researchers suspect decentralized storage systems may have allowed communities like Kilisa Tepe to endure while larger palace economies failed. Unlike heavily centralized capitals, Kilisa Tepe may have functioned as a flexible redistribution hub capable of adapting to trade disruptions and climate instability. There is also evidence that the settlement maintained unusually organized administrative systems. Excavations uncovered seal impressions used for tracking goods and controlling storage access. These seals indicate bureaucratic oversight far beyond what archaeologists expected from a settlement of this scale. Some symbols resemble Hittite administrative traditions, while others do not match known systems at all. This has fueled speculation that Kilisa Tepe may have been a hybrid cultural zone where multiple traditions merged together. Located along a strategic corridor connecting inland Anatolia to the Mediterranean coast, the settlement likely interacted with Hittites, Assyrians, local Anatolian groups, and maritime traders. Its technological methods may therefore represent accumulated knowledge transferred across several civilizations. Another unresolved mystery involves fire damage throughout the site. Many buildings show signs of intense burning events, yet in some cases the destruction appears to have strengthened the structures instead of weakening them. High temperatures transformed portions of the mud brick into hardened ceramic-like material. Some walls became more resistant after burning, preserving them for thousands of years. The strange part is the consistency. Certain burned layers appear too evenly heated to result from random accidental fires alone. This has led to controversial theories suggesting ancient builders may have understood, at least partially, how controlled heating could improve structural durability. While there is no evidence of industrial kiln-fired architecture on a large scale, the possibility that ancient builders experimented with thermal strengthening techniques remains difficult to dismiss completely. Even the location of Kilisa Tepe adds to its mystery. The settlement stood near a narrow passage through the Taurus Mountains, one of the key corridors linking central Anatolia with the Mediterranean world. Whoever controlled this route could monitor trade, migration, military movement, and resource transport. During periods of instability, such corridors became lifelines, and that may explain why Kilisa Tepe survived when larger, wealthier cities vanished. Unlike massive ceremonial capitals dependent on imperial systems, Kilisa Tepe appears practical, adaptive, and technologically optimized for survival. Its builders focused less on monuments and more on resilience. Stable temperatures, protected grain reserves, durable foundations, water management, and administrative control. Do you think ancient civilizations understood engineering far beyond what modern history admits? Share your thoughts in the comments below. Lepenski Vir defies the expected timeline of human development. Long before cities, long before writing, And even before agriculture had fully taken hold across Europe, a community emerged along the banks of the Danube River that seemed to understand space, geometry, and symbolic art at a level that should not yet exist. Located in what is now Serbia, within the dramatic landscape of the Danube's Iron Gates Gorge, this site dates back to roughly 7,000 to 6,000 BCE. That places it over 8,000 years before the present, at a time when most human groups in Europe were still mobile hunter-gatherers. Yet, what was uncovered here suggests something far more complex. Something organized, deliberate, and possibly encoded with knowledge we still struggle to interpret. The modern story of Lepenski Vir begins in the mid-20th century. In 1965, Serbian archaeologist Dragoslav Srejovic led systematic excavations in advance of a hydroelectric project that threatened to flood the region. What he and his team uncovered would quickly challenge long-standing assumptions about prehistoric Europe. Beneath layers of sediment, they revealed not scattered remains of temporary shelters, but a structured settlement rows of houses, carefully laid out, each with a consistent and highly unusual architectural form. Over the course of several excavation seasons between 1965 and 1970, more than 130 structures were documented, along with numerous stone sculptures and burial sites. This was not a transient camp. It was a designed environment. The first major anomaly emerged from the architecture itself. Every house at Lepenski Vir followed a remarkably consistent blueprint. A trapezoidal shape with a broad front and narrower rear, often aligned toward the Danube. The floors were made of a hardened limestone plaster, smoothed and flattened with a level of precision that is difficult to reconcile with Stone Age tools. At the center of each structure lay a rectangular hearth, placed with near-perfect symmetry. Measurements taken from multiple dwellings show that the proportions of these houses were not random. Ratios between width, length, and internal divisions appear consistent across the site. When compared to other Mesolithic settlements in Europe, most of which consisted of circular or irregular huts, Lepenski Vir stands apart. There is no gradual evolution toward this design in nearby regions. It appears suddenly, fully formed. As excavations expanded, further layers of complexity began to emerge. Archaeologists identified multiple phases of occupation, each showing subtle changes. In earlier phases, the structures were smaller and more varied, but by the peak period of the settlement, the trapezoidal design had become standardized. This suggests a transition from experimentation to a codified architectural system. Even more intriguing is the spatial organization of the entire settlement. Houses were not placed randomly. They were arranged in rows that followed the curve of the riverbank, all oriented toward a prominent natural feature across the Danube, the mountain known as Treskovac. Some researchers have proposed that the angle of the trapezoidal houses mirrors the slope or silhouette of this mountain, raising the possibility that the builders were intentionally reflecting the landscape in their architecture. By the late 1960s, the discoveries took an even more unexpected turn. Excavators began uncovering sandstone sculptures buried within or near the houses. These were not crude carvings. They were carefully shaped, often weighing several kilograms, and featuring distinct, almost haunting faces. The eyes were deeply set, the mouths wide and ambiguous, and the overall form suggested a fusion of human and fish-like characteristics. This is particularly striking given the site's proximity to the Danube, one of Europe's richest freshwater ecosystems. Large fish species such as sturgeon would have been a major resource for the inhabitants. But the sculptures go beyond simple representation. Their stylization, symmetry, and repeated motifs indicate a symbolic or ritual significance that is still not fully understood. In total, Over 70 such sculptures have been documented, many associated with specific houses, suggesting that they were not communal monuments, but belonged to individual households. This raises questions about belief systems, identity, and possibly even social hierarchy. When compared to other known art from the same period, such as the cave paintings of Western Europe, the Lepenski Vir sculptures are unique in both medium and style. They are not narrative scenes. They are objects portable, personal, and intensely abstract. The level of craftsmanship, especially in shaping hard sandstone with primitive tools, implies a significant investment of time and skill. Further excavations revealed another layer of complexity: burial practices. Human remains were often found beneath the floors of the houses, sometimes in extended positions, sometimes in seated or flexed arrangements. In several cases, skulls were separated and placed deliberately within the structure, occasionally near the hearth. This suggests a form of ancestor veneration or ritual continuity between the living and the dead. Radiocarbon dating places these burials firmly within the same time frame as the occupation of the houses, indicating that this was a sustained cultural practice rather than an isolated event. By the 1970s, as the excavation data accumulated, researchers began to quantify what they were seeing. The site covered an area of approximately 2,000 square meters, with a density of structures that implies a stable population over multiple generations. Analysis of animal remains shows a heavy reliance on riverine resources, particularly fish, which could explain the semi-sedentary lifestyle of the inhabitants. However, this alone does not account for the architectural precision or artistic complexity. Comparable fishing communities elsewhere in Europe did not produce anything similar. The gap is not just cultural, it is structural. One of the most debated aspects of Lepenski Vir is the question of knowledge. The geometric consistency of the houses has led some researchers to explore whether the builders were using an implicit system of measurement or proportion. While there is no direct evidence of written mathematics, the repeated accuracy across dozens of structures suggests more than trial and error. Experimental archaeology has shown that achieving such consistency with simple tools is possible, but it requires a clear conceptual model and a method of transferring that model across multiple builds. In other words, knowledge had to be shared, preserved, and applied systematically. As research continued into the late 20th and early 21st centuries, new technologies brought additional insights. Microscopic analysis of the plaster floors revealed multiple layers, indicating maintenance and long-term use. Isotopic studies of human remains suggested a diet heavily dominated by fish, with limited reliance on early agriculture even as farming began to spread into the region. This places Lepenski Vir at a cultural crossroads caught between the Mesolithic world of hunter-gatherers and the emerging Neolithic world of farmers. Yet instead of showing a gradual transition, the site appears to represent a parallel development, one that followed its own trajectory before eventually being absorbed or replaced. By around 6000 BCE, the distinctive features of Lepenski Vir begin to disappear. The trapezoidal houses are replaced by more typical Neolithic structures, and the unique sculptures cease to appear. There is no clear evidence of conflict or destruction. Instead, the change seems gradual but decisive, as if a cultural system that had persisted for centuries was suddenly rendered obsolete. This raises one of the most persistent questions about the site. Why did such a unique and sophisticated tradition emerge so early, and why did it not continue? If a society without writing or formal mathematics could achieve this level of precision and symbolic complexity, then where did that knowledge come from, and could it have been lost to history? What do you think? Share your perspective in the comments below. civilization built an entire religious network that could predict decisions, guide rulers, and influence entire regions without writing a single word. At Pachacamac, located about 40 kilometers southeast of modern-day Lima, a sprawling complex of temples and pyramids once functioned as one of the most powerful spiritual centers in ancient South America. Covering more than 600 hectares, the site operated continuously for over 1,000 years. Yet what makes Pachacamac extraordinary is not just its scale, but the system it sustained, a system that appears to have processed information, produced predictions, and maintained authority across vast distances without any known writing system, mechanical tools, or recorded calculations. It is not simply a ruin. It is the remnant of something that behaved like a machine, but left no blueprint behind. The first detailed accounts of Pachacamac came not from archaeologists, but from Spanish chroniclers during the conquest of the Inca Empire in the early 16th century. In 1533, forces under Hernando Pizarro arrived at the site, drawn by reports of immense wealth and a powerful oracle. Chroniclers such as Pedro Chiesa de Leon described Pachacamac as a pilgrimage center where individuals traveled hundreds, sometimes over 1,000 kilometers, to seek answers from a deity believed to control earthquakes and fate. What they encountered was not a chaotic religious site, but a highly organized complex, temples aligned along ceremonial routes, large plazas designed to host crowds, and restricted inner sanctuaries where only priests could enter. At the center stood a wooden idol representing the god Pachacamac. According to Spanish accounts, this idol was believed to speak through priests, delivering answers that shaped political and personal decisions. The Spanish destroyed the idol shortly after their arrival. Gold and offerings were looted, and the oracle system, once the core of the site's power, collapsed almost immediately. From that moment forward, Pachacamac transitioned from a living system into an archaeological mystery. Systematic excavations began centuries later. In the late 19th century, explorers such as Max Ewell conducted the first scientific investigations at Pachacamac around 1896. Ewell identified multiple construction phases, revealing that the site was not built by a single civilization, but developed over time by successive cultures, including the Lima culture, circa 200 to 700 CE, the Wari Empire, and later the Inca. Each excavation phase uncovered new layers of complexity. Archaeologists found carefully constructed adobe pyramids, some rising over 30 meters high, composed of millions of hand-shaped mud bricks. Radiocarbon dating confirmed continuous occupation spanning more than a millennium. In burial areas, hundreds of mummies were discovered, often accompanied by textiles, ceramics, and ritual offerings, indicating a highly organized belief system tied to both death and pilgrimage. Excavations in the 20th and 21st centuries revealed road networks connecting Pachacamac to distant regions of the Andes. These routes suggest that the site functioned as a hub within a broader pilgrimage system, drawing participants from across Western South America. Chemical analysis of artifacts has shown that materials originated from diverse ecological zones, including coastal, highland, and jungle environments, further confirming long-distance interaction. Despite these discoveries, one element remained absent. There is no evidence of a written language or formal recording system. No inscriptions, no codices, no carved texts. The system operated, evolved, and influenced entire populations without leaving behind its instructions. The most overlooked yet scientifically striking mystery of Pachacamac lies not in its rituals, but in its material. The entire complex was built primarily from adobe sun-dried mud bricks composed of soil, sand, water, and organic fibers. In modern engineering, adobe is considered a low-durability material. Under exposure to rain, humidity, and seismic activity, it typically degrades within decades, if not properly maintained. Yet Pachacamac has endured for over 1,000 years. This endurance becomes even more perplexing when environmental data is considered. The region experiences periodic El Niño events, which bring intense rainfall capable of eroding unprotected earth structures. In addition, Peru lies along a major seismic zone, where earthquakes regularly impact structural stability. Adobe construction, lacking tensile strength, is especially vulnerable to collapse under such conditions. And yet, large sections of Pachacamac remain standing. Laboratory analysis of adobe samples has revealed variations in composition. Some bricks contain higher concentrations of sand and organic fibers, which may improve resistance to cracking. Structural studies suggest that the pyramids were built in layered segments, possibly allowing them to absorb stress more effectively. However, these explanations are incomplete. Modern reconstructions using similar materials and techniques have struggled to replicate the same level of long-term durability under comparable environmental stress. For comparison, Roman concrete used in structures like the Pantheon has been studied extensively for its self-healing properties due to volcanic ash reactions. Pachacamac's adobe, by contrast, lacks such chemical advantages, yet demonstrates unexpected resilience. In engineering terms, it behaves beyond its known limits. This raises a fundamental question. Did ancient builders possess a construction methodology that has not been fully understood or replicated today? Beyond its physical structure, Pachacamac's greatest enigma lies in its function as an oracle. Historical accounts indicate that responses given at the site were trusted across vast distances and social classes. Leaders made decisions based on its guidance. Pilgrims invested months, even years, to reach it. From a systems perspective, this implies a mechanism for gathering, processing, and delivering information. But how? Without writing, data storage becomes nearly impossible at scale. Without instruments, predictive modeling seems unlikely. Some researchers propose that priests gathered intelligence from travelers, effectively creating an early information network. Others suggest that ritual performance and psychological influence played a role in shaping perceived accuracy. However, neither explanation fully accounts for the consistency and authority attributed to the oracle over centuries. The destruction of the central idol provides an additional clue. When the Spanish eliminated this single object, the entire oracle system ceased to function. This suggests that the idol was not merely symbolic, but integral, possibly acting as a focal point for ritual, authority, or even information control. In modern terms, it resembles the removal of a central processing unit from a network. The infrastructure remains, but the system stops. Despite its size and importance, Pachacamac lacks defensive walls or military fortifications. Archaeological surveys have found no evidence of large-scale conflict within the site. This is highly unusual for a center of such influence. One explanation is that Pachacamac functioned as a sacred neutral zone. Violating it may have carried severe cultural or religious consequences. Another possibility is that its power was not military, but ideological control over belief systems can, in some cases, surpass physical force. Interestingly, even when the Inca Empire expanded into the region in the 15th century, they did not destroy Pachacamac. Instead, they incorporated it, building new structures such as the Temple of the Sun while preserving the oracle's function. This continuity across different civilizations suggests that Pachacamac's significance transcended political boundaries. So what do you think, was Pachacamac truly just a religious center, or something far more advanced hidden in plain sight? Share your thoughts in the comments below. Only a few meters above the Mediterranean plain near modern-day Mersin, Turkey, Göbekli appears to be nothing more than an ordinary archaeological mound, but beneath its soil are more than 30 layers of civilization, stretching back over 9,000 years. Long before the pyramids of Egypt, before Stonehenge, and before the first empires of Mesopotamia, people at Göbekli were already building fortified walls, engineering drainage systems, organizing urban districts, and possibly mastering forms of metal technology thousands of years ahead of accepted history. What makes Göbekli so disturbing to archaeologists is not its size, but its timing. Too many advanced ideas appear here too early, as if fragments of lost technical knowledge emerged centuries before the rest of the ancient world caught up. The first major excavations at Göbekli began in 1937 under British archaeologist John Garstang. What initially appeared to be a simple settlement mound soon revealed one of the deepest cultural sequences ever discovered in the Eastern Mediterranean. Layer after layer exposed uninterrupted habitation from the Neolithic period all the way to the Byzantine era. Archaeologists uncovered houses, storage facilities, defensive walls, workshops, ovens, copper tools, and evidence of organized social systems spanning nearly 9 millennia. The most shocking discovery came from levels dated to around 4,500–4,300 BCE, where hidden beneath later settlements was a massive fortified complex with thick defensive walls and controlled entrances, centuries older than many fortifications traditionally associated with early urban civilization. At the time, historians believed societies this ancient were still relatively simple farming communities. Göbekli challenged that assumption immediately. The greatest mystery surrounding Göbekli is its evidence of extremely early metallurgy. Archaeologists discovered copper tools, slag remains, furnace structures, and traces of controlled heating techniques dating back to the 5th millennium BCE. That date is critical because mainstream history long taught that sophisticated metalworking emerged gradually in regions such as Mesopotamia and Anatolia during later Chalcolithic development. Yet Göbekli suggests certain communities may already have understood advanced thermal control long before metallurgy supposedly became widespread. Some copper artifacts found at the site show unusually refined composition for their age. Metallurgical analysis revealed reduced impurity levels that imply more than accidental melting. The copper appears to have undergone deliberate heating management, suggesting ancient craftsmen may have understood airflow regulation and temperature stabilization inside primitive furnaces. This becomes even stranger when compared to other early metalworking sites. At many prehistoric settlements, copper production appears crude and inconsistent. Ore was often heated in open fires with limited temperature control, producing weak or heavily contaminated metal. But evidence at Göbekli points toward enclosed furnace systems capable of sustaining significantly higher temperatures. Researchers identified furnace remains with ventilation channels that may have amplified airflow naturally through pressure differences and wind direction. In modern engineering terms, this resembles a primitive draft furnace system. The implications are enormous because copper melts at approximately 1,085 degrees Celsius. Reaching and sustaining such temperatures consistently without advanced bellows or engineered furnaces should have been extremely difficult for Neolithic societies. Yet the evidence suggests the inhabitants of Göbekli may have achieved precisely that. Some archaeologists propose the inhabitants unintentionally discovered natural air pressure principles by positioning furnaces to exploit Mediterranean winds. If true, this would represent a major technological leap thousands of years earlier than expected. The mystery deepens further because this knowledge does not appear to spread normally through the archaeological record. In many nearby regions, metallurgy remains comparatively primitive for centuries afterward. It is almost as if Ümüktepe briefly possessed technical knowledge that either disappeared, remained isolated, or was never fully transmitted to surrounding civilizations. Even more unsettling is the possibility that metallurgy at Ümüktepe was connected to emerging social hierarchy. Control over metal production would have created enormous economic and political power. Some researchers believe the fortified structures at the site may have existed partly to protect valuable metallurgical activity and trade networks. If correct, Ümüktepe may represent one of the earliest examples of technology directly reshaping political organization in human history. The defensive walls at Ümüktepe remain one of its most controversial discoveries. Dating to roughly 4,500 BCE, the fortification system predates many famous ancient military structures by centuries. The walls were not simple barriers of piled mud. Excavations revealed multi-layered construction techniques, using compacted earth reinforced with stone and carefully angled surfaces designed to resist collapse. Some entrances appear intentionally narrowed, forcing movement into controlled channels similar to defensive choke points used in much later military architecture. This raises an uncomfortable question. Who are they defending themselves against? Traditional models of early Neolithic societies describe relatively small agricultural communities with limited organized warfare. Yet Ümüktepe's fortifications imply sustained threats serious enough to justify large-scale defensive engineering. Compared to early settlements in Mesopotamia, many of which lacked comparable fortification complexity during the same period, Ümüktepe appears unusually militarized. The site almost looks like a civilization preparing for conflict before large-scale urban warfare officially existed. Another major mystery lies beneath the buildings themselves. Despite thousands of years of environmental change, many architectural layers at Ümüktepe remained remarkably stable. Geological studies suggest the inhabitants developed primitive but highly effective foundation systems to manage moisture and soil movement. Builders compacted alternating layers of earth, gravel, and organic material beneath structures, creating semi-flexible foundations capable of distributing pressure while improving drainage. Modern engineers use similar principles in floating foundation systems designed for unstable terrain. The strange part is not simply that the system worked, but that people living over 6,000 years ago appear to have discovered these principles experimentally without formal mathematics, physics, or engineering science. This pattern appears repeatedly at Ümüktepe. Practical technological solutions emerging centuries before theoretical knowledge supposedly existed. The settlement also demonstrates signs of environmental planning surprisingly advanced for its era. Several structures appear positioned to maximize Mediterranean airflow while minimizing heat accumulation during summer months. Archaeologists noted recurring orientation patterns in building placement that may reflect intentional passive cooling strategies. Storage pits and food facilities were lined with specialized clay coatings capable of limiting humidity and insect contamination. Some chambers maintained relatively stable temperatures despite external climate fluctuations. Modern sustainable architecture increasingly relies on passive cooling and thermal regulation to reduce energy consumption. Yet similar concepts may already have existed at Ümüktepe nearly 7,000 years ago. This suggests the inhabitants possessed a sophisticated understanding of local microclimates and environmental adaptation long before such ideas were formally studied. Perhaps the most haunting aspect of Ümüktepe is its continuity. The mound contains more than 30 cultural layers spanning from the Neolithic period through Roman and Byzantine occupation. Very few sites remain continuously important for such an immense length of time. Civilizations rose and collapsed, empires disappeared, and entire trade systems vanished. Yet people repeatedly returned to Ümük Tepe generation after generation. One explanation is geography. The site occupied a strategically valuable position near fertile land and Mediterranean trade routes. But some researchers suspect something more significant existed there. Accumulated engineering knowledge passed through centuries of occupation. Over time, each civilization may have inherited fragments of practical technologies developed by earlier inhabitants. If so, Ümük Tepe was not merely a settlement. It may have been one of humanity's earliest long-term centers of technological experimentation. Do you think Ümük Tepe was simply ahead of its time? Or could it be evidence that ancient civilizations once possessed knowledge history has completely forgotten? Share your thoughts in the comments below. Not far from the Mediterranean coast west of Alexandria, beneath layers of drifting desert sand and collapsing farmland, archaeologists uncovered the remains of what was once one of the largest Christian pilgrimage cities on Earth. Abu Mena, built around the tomb of Saint Manaz in the 4th century AD, was not supposed to survive. The city stood on unstable clay-rich soil saturated by underground moisture in a semi-arid environment with limited natural water sources. Yet, for nearly 1,000 years, enormous basilicas, bath complexes, storage halls, underground chambers, workshops, and pilgrimage roads remained standing across a sprawling urban centre that may have hosted tens of thousands of visitors annually. Even more disturbing to engineers today is the fact that many of the ancient structures survived far longer than the modern ground beneath them. The rediscovery of Abu Mena began in the early 20th century when German archaeologist Karl Maria Kaufmann conducted excavations between 1905 and 1907 after local reports of buried ruins southwest of Alexandria. What emerged shocked historians. Beneath the sand was an enormous Byzantine religious metropolis covering several square kilometers, centered around one of the earliest and most important Christian pilgrimage shrines outside Jerusalem. Excavations later revealed massive churches, hostels, industrial zones, baptisteries, cistern systems, and underground architectural layers stretching far beyond what researchers initially expected. But the deeper archaeologists dug, the stranger the site became. The first major mystery involved the ground itself. Modern geological surveys show that Abu Mena sits atop highly unstable clay and silt, deposits vulnerable to water saturation and subsidence. In many regions today, constructing heavy stone buildings on such soil without reinforced foundations would be considered extremely risky. Yet Abu Mena supported monumental basilicas with thick masonry walls and wide-span courtyards for centuries. Some foundation sections exceeded several meters in width, distributing the load across soft terrain in ways that resemble primitive geotechnical engineering. UNESCO eventually classified Abu Mena as a World Heritage Site in danger because rising groundwater in the modern era has caused severe structural collapse. Ironically, the ancient city remained stable for nearly 1,500 years before modern irrigation projects in the Nile Delta altered underground water levels. Entire sections that survived Byzantine wars, earthquakes, and desert erosion began sinking only after 20th century agricultural expansion increased soil saturation. This created a disturbing paradox. How could ancient builders maintain structural stability on fragile terrain longer than the modern infrastructure systems? Some engineers believe the builders understood groundwater behavior far better than previously assumed. Excavations uncovered layered foundation systems containing compacted rubble, porous fill materials, drainage channels, and hollow cavities beneath major structures. These may have functioned as pressure distribution zones or moisture control systems, reducing hydrostatic stress beneath heavy buildings. In modern engineering, similar concepts are used in floating foundations and subsurface drainage stabilization. Yet no surviving texts fully explain how these systems worked. Several underground spaces discovered beneath the basilica complex appear particularly unusual. Some chambers had no obvious religious or storage purpose. Others were positioned directly beneath load-bearing sections of major buildings. Researchers proposed multiple theories: moisture ventilation, thermal regulation, seismic pressure release, or even intentional weight redistribution. What makes the mystery more intriguing is that some void spaces were carefully integrated into the original construction rather than added later. Comparisons with Roman engineering only deepen the puzzle. Roman builders often relied on deep stone footings anchored to bedrock whenever possible. Abu Mena lacked that advantage. Instead, his architects may have developed adaptive foundation systems suited for unstable wet clay, something remarkably advanced for late antique Egypt. The deeper implication is unsettling. If these underground systems truly functioned as pressure control or moisture management technology, then the engineers of Abu Mena possessed a level of environmental understanding historians rarely associate with Byzantine-era desert settlements. Water itself forms another major mystery. Abu Mena was built in a region with limited natural freshwater access, yet historical sources describe enormous pilgrimage crowds arriving from across the Byzantine world. Pilgrims travelled from Anatolia, North Africa, Syria, Italy, and even parts of the Balkans to visit the shrine of Saint Menaz, believed to possess miraculous healing powers. Maintaining such a population in a semi-desert environment required massive logistical coordination. Archaeologists discovered large cisterns, channels, reservoirs, wells, and hydraulic installations throughout the city. Some storage systems were lined with highly durable waterproof mortar containing lime, crushed ceramics, and mineral additives similar to Roman pozzolanic concrete. Certain sections still resist water penetration after more than a millennium. Material scientists comparing Abu Mena's hydraulic coatings to Roman harbour concrete found notable similarities in salt resistance and moisture durability. However, the precise formulation of some compounds used at Abu Mena remains uncertain. The coatings survived cycles of heat, salt crystallization, and groundwater exposure that destroyed many neighbouring structures. How the city consistently supplied water to massive pilgrimage populations remains partly unresolved. Some historians estimate that during peak religious festivals, thousands of visitors could occupy the site simultaneously. Feeding and hydrating such numbers would have required advanced storage management far beyond what most ancient desert settlements possessed. Then there were the workshops. One of the most famous discoveries at Abu Mena involved the production of small pilgrimage flasks known as ampullae. These clay vessels, stamped with the image of Saint Menas standing between camels, were filled with holy water or sacred oil and carried across the Christian world. Tens of thousands have been discovered in Egypt, Germany, France, Italy, Turkey, and the Levant. What astonished archaeologists was the degree of manufacturing standardization. The flasks were remarkably uniform in size, shape, iconography, and firing quality. Many appear to have been mass-produced using organized workshop systems, approaching industrial-scale output centuries before mechanized manufacturing. Some researchers described Abu Mena as operating a proto-industrial pilgrimage economy. This raises another difficult question. How did a desert religious city sustain enough fuel, clay processing, labor specialization, transportation networks, and trade coordination to distribute products across the Mediterranean world at such scale? The discovery suggests Abu Mena may not have been merely a spiritual center. It may also have functioned as one of the most organized economic and manufacturing hubs in Byzantine Egypt. The city also displayed evidence of sophisticated urban planning unusual for many pilgrimage centers of the period. Roads connected major structures through carefully arranged circulation zones. Pilgrim hostels, baths, worship spaces, and commercial districts were integrated into an organized urban layout rather than chaotic expansion. Certain pathways appear designed to regulate crowd movement toward the shrine complex. Thermal engineering may have played a role as well. Some underground chambers maintained lower temperatures than surrounding surface areas, possibly through passive cooling and airflow control. Similar techniques appeared in Persian desert architecture centuries later, including wind catch systems and subterranean cooling corridors. Whether Abu Maina independently developed comparable environmental engineering remains debated. If true, the city may represent an early example of climate-adaptive architecture designed specifically for survival in harsh desert conditions. By the 7th century, political instability, changing trade routes, and religious shifts led to the decline of Abu Maina. Over time, the city was abandoned and buried beneath desert sand. Yet despite centuries of neglect, many underground structures remained intact. Modern radar surveys suggest large parts of the city are still buried beneath the surrounding terrain. Some archaeologists believe only a small portion of Abu Maina has been excavated. The site also challenges the idea that post-Roman societies lacked advanced engineering. Abu Maina reveals sophisticated knowledge of groundwater control, hydraulic materials, urban planning, and foundation engineering. Its builders managed to keep a massive city stable on weak, waterlogged soil for centuries. Buried beneath the soil of southeastern Anatolia lies a site that quietly disrupts the timeline of human technology. At first glance, Kurtik Tepe appears unremarkable, just another low mound overlooking the Tigris River in modern-day Turkey. But what has been uncovered here challenges a foundational assumption about human history: that advanced craftsmanship, complex symbolism, and refined material technology only emerged after agriculture, after cities, after civilization itself had already begun. Kurtik Tepe tells a different story, one where technological sophistication appears before the systems we believed were necessary to support it, forcing a re-evaluation of how and when human innovation truly began. The site entered modern archaeology in the early 2000s, not through deliberate exploration but through urgency. Planned dam construction along the Tigris triggered a wave of rescue excavations, and Kurtik Tepe quickly emerged as one of the most significant discoveries in the region. As the first trenches cut into the mound, archaeologists encountered dense occupational layers dating from approximately 11,500 to 10,000 years ago, firmly within the pre-pottery Neolithic A period. At that time, humanity was believed to exist in small, mobile hunter-gatherer groups, with limited technological complexity. Yet almost immediately, the evidence at Kurtik Tepe began to contradict that narrative. Layer by layer, the excavation revealed a settlement that was not temporary but persistent. Circular and oval dwellings appeared in repeating patterns, often rebuilt in the same locations, indicating long-term occupation. Beneath these structures, a remarkable practice emerged. The dead were buried directly under the floors of the living. Over 1,000 burials have been documented so far, forming one of the densest early Neolithic burial assemblages ever discovered. This alone suggested a complex relationship between space, memory, and ritual. But it was not the burials themselves that shocked researchers, it was what they contained. In grave after grave, archaeologists uncovered immense quantities of beads. Not dozens, not hundreds, but thousands. Some individuals were buried with more than 10,000 beads, meticulously arranged around the body. These beads were crafted from stone, bone, and shell, each only a few millimeters in size. Many displayed perfectly centered perforations, suggesting controlled and repeatable drilling techniques. Experimental reconstructions indicate that drilling a single bead using stone tools can take anywhere from several minutes to over an hour, depending on the material. When multiplied across thousands of beads in a single burial, the time investment becomes almost incomprehensible, potentially representing hundreds or even thousands of labor hours for a single individual's grave goods. Yet even this extraordinary display of labor and symbolic expression is overshadowed by the most perplexing discovery at Kurtik Tepe: the stone vessels. Across multiple excavation seasons, thousands of carved stone bowls and containers have been recovered, many made from hard materials such as basalt and dense limestone. These are not crude utilitarian objects. Their walls are thin, often uniformly so, and their surfaces are polished to a level that reflects light. Some vessels exhibit near-perfect symmetry, while others are decorated with intricate incised patterns, parallel lines, geometric repetitions, and fine detailing that appears consistent across multiple pieces. This level of craftsmanship becomes even more striking when placed in its technological context. During the pre-pottery Neolithic A, there is no evidence of metal tools. No copper chisels, no bronze blades, no iron implements. The available toolkit consisted primarily of flint, stone hammers, and grinding stones. Under these constraints, shaping hard stone into thin-walled, polished vessels is technically possible, but extremely inefficient. Modern experimental archaeology suggests that producing a single vessel of comparable quality using stone tools alone could require dozens to hundreds of hours of continuous work. And yet, at Kurtik Tepe, these vessels exist not as rare masterpieces, but as a widespread and repeated form. This creates a fundamental contradiction. Either the inhabitants of Kurtik Tepe operated within a social system capable of organizing massive labor investments on a scale not typically associated with early sedentary groups, or they possess techniques that dramatically increased efficiency techniques that remain largely invisible in the archaeological record. Some researchers have proposed the use of advanced abrasive methods, combining fine sand with water to gradually grind and hollow stone surfaces. Others suggest rotational drilling mechanisms using wooden shafts and abrasive slurry, effectively functioning as primitive lathes. However, no direct evidence of such tools has been recovered. If they existed, they were likely made from organic materials, wood, fiber, plant-based compounds that have long since decomposed. As excavation expanded, additional patterns reinforced the idea of unexpected complexity. The spatial organization of the settlement suggests planning rather than randomness. The repeated rebuilding of structures indicates continuity of occupation across generations. More importantly, the variation in burial goods points to early forms of social differentiation. Some individuals were buried with minimal offerings, while others were accompanied by vast quantities of beads and finely crafted objects. This uneven distribution implies the existence of symbolic hierarchies, roles, identities, or statuses that were recognized and materialized through objects. When compared to later Neolithic sites such as Çatalhöyük, which dates several thousand years after Kurtik Tepe, the anomaly becomes even more pronounced. Çatalhöyük displays clear evidence of agriculture, dense architectural planning, and complex artistic expression. It fits the traditional model of gradual technological and social progression. Yet at Kurtik Tepe, long before these developments fully emerged, we already see evidence of highly refined stone craftsmanship and intricate symbolic systems. In some respects, the precision of Kurtik Tepe's stone vessels rivals, or even exceeds, that of later, more advanced societies. This inversion challenges the linear model of human development. It suggests that technological capability does not necessarily follow a simple progression from primitive to advanced. Instead, it may appear in bursts emerging under specific conditions, then disappearing or transforming in ways that are not always preserved in the archaeological record. The question then becomes not just how these people achieved such precision, but why similar techniques are not consistently observed in subsequent periods. Perhaps the most elusive aspect of Kurtik Tepe lies in what cannot be seen. The archaeological record preserves stone and bone with relative clarity, but organic materials, wood, fibers, adhesives rarely survive over 10,000 years. And yet, the level of precision observed in both the beads and the stone vessels strongly implies the use of supplementary tools and materials. Abrasives, bindings, rotational devices, and possibly even composite tool systems may have played a role. These would have been essential for achieving the observed results, yet they leave little to no trace after millennia of decay. What remains, therefore, is a partial record. We see the outcomes, but not the full process. The artifacts stand as isolated endpoints of a technological system that is largely invisible. This creates the illusion that the achievements are inexplicable, when in reality, the explanation has simply been lost. What do you think really explains this level of precision so early in human history? And are we underestimating the true technological capabilities of our ancestors? Share your thoughts in the comments below. Located within the volcanic plains of Cappadocia in central Turkey, archaeologists uncovered a settlement older than Stonehenge, older than the pyramids, and nearly as old as the first permanent human communities on Earth. Known today as Asikli Hoyuk, this 10,000-year-old settlement contains evidence of urban planning, advanced obsidian engineering, organized architecture, and one of the oldest possible brain surgeries ever discovered. The deeper researchers excavated, the less this place resembled a primitive village, and the more it looked like the beginning of civilization itself. The site was first identified during archaeological surveys in the 1960s around the Melendez River basin, but large-scale excavations officially began in 1989 under Turkish archaeologist Ufuk Esin from Istanbul University. At first, researchers believed Asikli Hoyuk was simply another Neolithic mound buried beneath the Cappadocian soil. Instead, excavation layers revealed more than 400 interconnected mud brick buildings constructed across centuries of rebuilding. Radiocarbon dating pushed the settlement back to approximately 8,207,400 BC, making it one of the oldest known large-scale sedentary communities in Anatolia. Long before urban centers like Çatalhöyük emerged, Asikli Hoyuk was already experimenting with architecture, specialized labor, organized living spaces, and technological systems that should not have existed so early in human history. One of the most baffling mysteries surrounding Asikli Hoyuk is the survival of its mud brick architecture for more than 10,000 years in an environment exposed to severe seasonal temperature shifts. The settlement was built almost entirely from sun-dried mud brick reinforced with straw, ash, and organic material. Under normal conditions, structures like these deteriorate rapidly due to erosion, moisture expansion, and thermal cracking. Yet many walls at Asikli Hoyuk remained structurally recognizable after millennia underground. Archaeologists discovered that the inhabitants repeatedly rebuilt homes directly on top of previous structures, eventually creating an archaeological mound nearly 16 meters high. What stunned researchers was the consistency of the engineering across generations. Wall thickness, room proportions, and structural alignment remained remarkably stable for centuries, suggesting that builders understood balance, weight distribution, and foundational reinforcement far earlier than expected for Neolithic societies. Microscopic analysis of the bricks revealed carefully controlled mixtures of clay, plant fibers, and ash, with some samples showing signs of moisture regulation before drying. A process comparable in principle to curing techniques used in modern earthen architecture. Compared with many later Neolithic settlements, where construction quality fluctuated wildly between generations, a sickly Hoyuk maintained extraordinary architectural uniformity. This level of standardization implies organized knowledge transfer and possibly even specialized builders within the community. For a society that had not yet developed metal tools, the precision appears disturbingly advanced. The most shocking discovery at a sickly Hoyuk came from a human skull excavated during the 1990s. The remains belonged to a young woman estimated to be between 20 and 25 years old. Her skull contained a circular opening with unmistakable evidence of deliberate cutting rather than accidental trauma. Even more astonishing, surrounding bone tissue showed partial healing, strongly suggesting that she survived the procedure for at least several days or possibly weeks afterward. Modern archaeologists classify the operation as a form of trepanation, an ancient cranial surgery involving drilling, scraping, or cutting into the skull. Similar procedures have been discovered in later cultures from ancient Peru to Bronze Age Europe, but the Asikli Hoyuk example may rank among the earliest ever identified anywhere in the world. The implications are extraordinary. To perform such a procedure, Neolithic people would have required some understanding of human anatomy, knowledge of where to cut without instantly killing the patient, methods of restraining or possibly sedating the individual, sharp enough surgical instruments, and some form of wound treatment afterward. The answer may lie in the thousands of obsidian blades uncovered throughout the settlement. Obsidian fractures at a molecular level sharper than modern surgical steel, and experimental medical studies have shown that obsidian scalpels can create incisions finer than stainless steel blades because their cutting edges can measure only a few nanometers thick. Archaeologists at Asikli Hoyuk uncovered expertly crafted obsidian tools so symmetrical and refined that some researchers compared them to precision instruments rather than primitive stone tools. This raises an uncomfortable possibility. The inhabitants of Asikli Hoyuk may have possessed a basic but functional understanding of surgery more than 10,000 years ago. The mystery becomes even darker because the woman's skull also showed evidence of severe infection before the operation. Some experts believe the procedure may have been an attempt to relieve pressure, treat trauma, or stop a dangerous illness. If correct, this was not ritual mutilation, it was medicine. Somehow, in an age before writing, metalworking, or formal science, humans attempted brain surgery with volcanic glass tools. Asikli Hoyuk stood near the rich obsidian deposits of Cappadocia, one of the largest volcanic glass sources in the ancient world. But archaeologists quickly realized the settlement was not merely using obsidian, it was processing and distributing it on an almost industrial scale. Excavations uncovered enormous quantities of blades, spearheads, cutting tools, unfinished fragments, and workshop debris spread throughout the settlement. Chemical sourcing studies later confirmed that obsidian originating near Asikli Hoyuk travelled hundreds of kilometres across Anatolia and into regions of the Levant, revealing organised trade networks far earlier than historians once believed possible. Some blades were manufactured using advanced pressure flaking techniques requiring extraordinary control, since even the slightest mistake would shatter the material instantly. Experimental archaeologists attempting to recreate these tools often require years of training before producing comparable results. Yet craftsmen at Asikli Hoyuk appear to have mastered the technique routinely. The settlement may have functioned as one of humanity's earliest specialized manufacturing centers, operating thousands of years before the rise of cities, kingdoms, or written economies. Unlike the chaotic layout seen in many prehistoric villages, a Sikli Hoyuk followed a surprisingly organized architectural system. Homes were constructed directly against one another, in tightly packed rectangular clusters, with almost no streets separating them. Researchers believe residents moved primarily across rooftops and entered buildings through openings in the ceilings using ladders. The design strongly resembles the later settlement of Catalhoyuk, though a Sikli Hoyuk predates it by nearly 1,000 years. Archaeologists suspect this unusual layout served several purposes simultaneously, including thermal insulation during harsh Anatolian winters, reinforcement against structural collapse, defense against external threats, and stronger social cohesion among interconnected family groups. The architecture also minimized exposed outer walls, conserving heat in a manner surprisingly similar to modern energy-efficient housing systems. What remains difficult to explain is how such sophisticated planning emerged so early in human history. There's little evidence of centralized rulers, kings, or monumental political authority at the site, yet the settlement maintained remarkably consistent urban organization across centuries. A Sikli Hoyuk functioned less like an accidental village and more like a carefully coordinated system. Another unresolved mystery involves indoor air management. Most homes at a Sikli Hoyuk contained hearths and evidence of continuous fire use, yet many rooms displayed unexpectedly low soot accumulation compared to what researchers anticipated. In enclosed mud brick buildings without modern chimneys, smoke inhalation should have been severe. Instead, archaeologists suspect the inhabitants developed primitive ventilation systems using roof openings, controlled airflow channels, or carefully positioned hearths that generated convection currents capable of moving smoke outside. Experimental reconstructions of the building suggest some houses could regulate indoor smoke more efficiently than certain medieval European structures built thousands of years later. If these theories are correct, a Sikli Hoyuk demonstrates an extremely early understanding of passive ventilation engineering long before formal architectural science existed. Do you think places like a Sikli Hoyuk prove that ancient civilization developed far faster than modern history tells us? Share your thoughts and theories in the comments below. A clear sequence has long been assumed. Survival comes first, then farming, then cities, and only after that monuments. But Nevala breaks that sequence completely. Here, more than 10,000 years ago, before metal, before written language, and even before agriculture had fully taken hold, people were cutting, shaping, and erecting massive stone pillars with a level of precision that appears premature. Not impossible, but disturbingly early. This is not just an archaeological site. It is a contradiction embedded in stone, a place where the expected order of human progress collapses under the weight of physical evidence that should not yet exist. Nevala Chori was discovered in the early 1980s during rescue excavations led by German archaeologist Harald Hauptmann, ahead of the construction of the Ataturk Dam on the Euphrates River. The urgency was immediate, as the rising waters would soon erase the site forever. Between 1983 and 1991, multiple excavation campaigns revealed a settlement dating to approximately 8,400 to 8,000 BCE, placing it firmly within the pre-pottery Neolithic B period. This was a time when humanity was only beginning to experiment with domestication, still deeply rooted in hunting and gathering. Yet beneath layers of soil, archaeologists uncovered something far more complex than expected. A structured settlement with stone-built houses, prepared floors, and a central building that stood apart from all others, not as a dwelling, but as a space that carried the unmistakable weight of ritual and intention. With each excavation season, the site revealed increasingly sophisticated features. Rectangular houses emerged first, their stone foundations and mud brick walls suggesting permanence rather than temporary occupation. This alone challenged assumptions about early human mobility, but it was the central structure that shifted the entire narrative. Measuring approximately 13 by 15 meters, this building contained a carefully prepared floor, resembling early terrazzo, created by crushing limestone, mixing it with water, and polishing it into a hardened, durable surface. This process required controlled heating and repeated labor, a level of material understanding that would not become common until much later periods. The effort involved implies not just knowledge, but organization, planning, and a shared purpose extending beyond survival. At the core of this structure stood the most enigmatic elements of Navalachory, T-shaped limestone pillars rising 2 to 3 meters in height, each weighing several tons. Their surfaces were not rough or incidental. They were deliberately shaped, smoothed, and in some cases engraved with relief carvings. When compared to other sites of similar age across the Levant, the contrast is stark. Elsewhere, architecture remained simple, dominated by circular huts, uneven stone placements, and minimal decorative work. Here, however, geometry appears controlled, surfaces refined, and space intentionally organized. Navalachory does not merely differ in scale, it differs in principle. The T-shaped pillars remain the most striking and least understood feature. Later echoed in nearby Göbekli Tepe, this architectural form is already fully realized at Navalachory. Each pillar consists of a vertical shaft supporting a horizontal block, forming a consistent and proportionally balanced T. The edges are straight, the planes flattened, and the transitions between surfaces precise. In a world without metal tools, without wheels, and without formalized systems of measurement, such consistency demands explanation. Experimental attempts to replicate similar shaping using flint tools demonstrate that it is possible, but only with extreme time investment and with far less precision. Yet the pillars here display uniformity, suggesting not trial and error, but a repeatable process guided by understanding. Even more compelling is the implied logistics behind their creation. Extracting limestone blocks of this size, transporting them across terrain, and erecting them upright would require coordinated effort among multiple individuals. It suggests planning, communication, and perhaps even early forms of leadership or specialization. In later civilizations, such as those of Egypt or Mesopotamia, such feats are supported by hierarchical systems and advanced tools. At Navalachory, those structures are not clearly visible, yet the outcome parallels their achievements in fundamental ways. This disconnect between technological output and presumed social capability is where the mystery deepens most significantly. Beyond architecture, the site yielded sculptures that further complicate the picture. Among them is a life-sized human head, carved from limestone, one of the earliest known examples of large-scale human representation. Its features are minimal, almost intentionally subdued, lacking the detailed facial expressions seen in later art. Instead, the emphasis rests on form and presence rather than identity. This suggests a level of abstraction, a conceptual approach to representation that goes beyond mere depiction. It implies that the people of Navalachory were not only shaping stone, but also shaping ideas, translating belief systems into physical form. Smaller figurines and carved fragments reinforce this impression. Though their meanings remain uncertain, their consistency suggests shared symbolism within the community. Unlike earlier Paleolithic art, which was often confined to caves and hidden spaces, the artistic elements at Navalachory are integrated directly into the architecture. They occupy public and communal areas, transforming the built environment into a medium of communication. This is not decoration in the conventional sense. It is a structured expression of belief embedded in stone and space. As more evidence emerged, the broader implication became unavoidable. Navali Chori presents a society that appears out of sequence. It demonstrates permanent architecture, organized spatial planning, and symbolic expression all existing before the widespread adoption of agriculture. Faunal remains indicate that hunting remained a primary subsistence strategy, while plant evidence suggests only early stages of cultivation. This means that the builders of Navala Chori were not fully agricultural, yet they were capable of organizing labor and resources on a scale previously thought unattainable for such groups. This challenges the traditional model of human development, which proposes that agriculture leads to surplus, surplus leads to hierarchy, and hierarchy enables monumental construction. At Navali Chori, the order appears reversed. The presence of a central ceremonial structure suggests that shared belief may have brought people together first, creating the conditions for cooperation. That cooperation may have enabled construction, and only later did agriculture emerge as a supporting system. In this framework, ideology, not economy, becomes the driving force of early civilization. Then, just as abruptly as it appears, Navala Chori disappears from the archaeological record. By around 8000 BCE, the site was abandoned. There is no clear evidence of conflict or destruction. It simply ceased to function. What follows is equally puzzling. Later, Neolithic settlements in the region do not show a direct continuation of its architectural sophistication. Instead, many revert to simpler forms, lacking the precision and monumentality seen here. The knowledge embedded in Navala Chori does not visibly evolve. It fades. This pattern, where advanced capability emerges suddenly and then vanishes or diminishes, appears in multiple ancient contexts. It raises difficult questions about how knowledge is preserved, transmitted, or lost. Was the expertise at Navala Chori localized to a specific group? Was it dependent on individuals whose knowledge did not survive? Or does it reflect a broader gap in our understanding of early human innovation? What do you think these pillars really represent, and how could such precision exist so early? Share your thoughts in the comments below. Northwestern Anatolia hides a Neolithic settlement that should not have existed in the way it did. Beneath layers of soil older than Stonehenge by nearly 4,000 years, the people of Aktopraklik Hoyuk appear to have mastered moisture control, structural engineering, thermal regulation, and organized urban planning around 8,500 years ago. Some of the construction principles discovered there resemble techniques later used in Roman foundations and Middle Eastern passive cooling systems, despite being separated by millennia. The site was systematically excavated during the 2000s ahead of modern development projects near Bursa in northwestern Turkey. Archaeologists uncovered multiple habitation layers dating roughly between 6,500 and 5,800 BC, including houses, burials, workshops, and unusually advanced floor systems preserved beneath compacted soil. What initially appeared to be a simple farming village soon became one of the strangest engineering puzzles of the Neolithic world. Most early Neolithic settlements expanded chaotically. Houses were added wherever space existed, creating dense and irregular clusters, and sites such as early Katal Hoyuk often grew organically with little evidence of geometric planning. Aktopraklik Hoyuk was different. Several houses were aligned along surprisingly consistent orientations, while distances between structures remained relatively uniform and pathways appeared intentionally preserved across generations. Archaeologists noticed repeated architectural patterns that implied some form of communal planning rather than random expansion. This is difficult to explain because no evidence of formal measurement tools has ever been found there. Yet maintaining architectural consistency over centuries would have required some type of standardized spatial understanding. Even small deviations repeated across generations should have produced disorder, but parts of the settlement retained a striking structural rhythm. Some researchers compare this phenomenon to the proto-urban organization later seen in Jericho or Halaf settlements in Mesopotamia, even though Aktapraklik-Hoyuk predates many of them. The mystery is not that these people built houses. The mystery is that they seem to understand settlement management thousands of years before cities officially existed. The most disturbing discovery at Aktapraklik-Hoyuk may be hidden beneath the houses themselves. Excavations revealed that many floors were not made from simple packed dirt. Instead, builders created layered systems composed of compacted clay, ash deposits, fine burned material, and small stones or gravel placed beneath living surfaces. At first, archaeologists believed these layers were accidental accumulations caused by repeated rebuilding over centuries, but later analysis suggested otherwise. The layers were intentional. This matters because the Bursa region experiences significantly higher humidity and groundwater exposure than the dry central Anatolian plateau. In humid environments, primitive mud floors normally crack, absorb moisture, develop mold, and structurally fail within relatively short periods. Yet many floor surfaces at Aktapraklik-Hoyuk remained remarkably stable. The engineering principles behind them appear surprisingly sophisticated. The gravel layers likely improved drainage by reducing capillary water rise from the ground, while the ash layers may have functioned as moisture absorbers that simultaneously stabilize the clay. Burned organic material can also reduce microbial growth and improve resistance to humidity-related decay. In modern civil engineering, similar principles are still used in subfloor drainage systems and moisture barriers. What makes this discovery unsettling is the age of the technology. These houses were built nearly 8,000 years before modern waterproof concrete. Some geoarchaeologists have even compared the layered flooring system to later Roman substructures that used crushed ceramics, volcanic ash, and compacted aggregate to control moisture infiltration. Roman builders achieved this around 2,000 years ago, but the people of Aktapraklik-Hoyuk may have been experimenting with primitive forms of the same environmental engineering 6,000 years earlier. No written language existed there, no engineering manuals existed, and no scientific framework had yet been created. Yet the results suggest long-term empirical knowledge accumulated through generations of experimentation. The larger question becomes impossible to ignore. How many centuries of trial and error would have been necessary for Neolithic builders to discover the exact combination of clay density, ash distribution, and drainage layering needed to stabilize homes in a humid climate? Another anomaly involves the walls themselves. Several structures at Aktapraklik-Hoyuk used unusually thick mud brick or compacted earthen walls, compared to the size of the buildings. Initially, this was interpreted as primitive overbuilding, the assumption that inexperienced builders simply made walls thicker for safety. But thermal studies on ancient earthen architecture suggest another explanation. Thick walls function as thermal mass. During the day, dense earthen materials absorb heat slowly, and at night they release that heat gradually, stabilizing indoor temperature fluctuations. In hot climates, this reduces daytime overheating, while in colder nighttime conditions it preserves warmth. This principle is nearly identical to passive climate engineering later used in Persian desert architecture, North African kasbahs, and even modern sustainable housing systems. Some entrances and internal hearth positions at the site also appear aligned with prevailing local wind directions. If intentional, this suggests the builders understood natural airflow circulation for for smoke ventilation and temperature management. That level of environmental adaptation is extraordinary for a settlement this old, especially because similar passive cooling strategies would later define advanced civilizations thousands of years afterward. The walls contained another mystery. Microscopic analysis revealed traces of plant fibers, straw fragments, and organic inclusions deliberately mixed into mud construction materials. This was not random debris, it was engineered reinforcement. Adding fibrous material into clay reduces shrinkage cracking during drying and improves tensile resistance, and the same principle survives today in adobe architecture and fiber-reinforced composite materials. The strange part is the consistency. Multiple buildings showed similar mixtures and similar ratios of organic tempering, suggesting builders already understood which combinations produce stronger and longer-lasting walls. In effect, they were practicing primitive materials engineering long before metallurgy, formal mathematics, or recorded architecture even existed. Not all buildings at Aktopraklik-Hoyuk served the same purpose. Archaeologists identified areas containing concentrated stone tools, bone-working debris, dense ash accumulations, and hardened work surfaces distinct from ordinary domestic houses. This suggests the settlement already possessed forms of spatial specialization, including living zones, production zones, craft activity areas, and possibly communal or ritual spaces. That level of organization is highly unusual for a Neolithic farming village. Most early settlements of similar age show less functional separation, but Aktopraklik-Hoyuk appears to have operated with a structured social logic closer to proto-urban communities. If true, then this site represents more than survival, it represents systems thinking. The dead were often buried beneath house floors, a practice known from other Anatolian Neolithic sites, but at Aktopraklik-Hoyuk burial distribution appears uneven. Some houses contained multiple generations of burials, while others contained none at all, and a few individuals were buried with unusual objects or in more deliberate positions. This may indicate the emergence of social hierarchy. If so, then the settlement was not merely an egalitarian farming community, but a society already developing social differentiation centuries before the rise of the first recognized cities. That possibility changes how archaeologists interpret the Neolithic transition entirely. Do you think the people of Aktopraklik-Hoyuk developed this engineering knowledge entirely on their own, or could traces of a forgotten prehistoric tradition have survived far longer than we realize? Share your thoughts in the comments below. Never destroyed, never looted, never abandoned to decay. Instead, sealed deliberately, carefully, and almost reverently beneath layers of stone and time. Hidden deep within the dense jungles of northern Guatemala, the Holmul Frieze Temple presents a contradiction that modern archaeology still struggles to resolve. Why would a civilization invest immense skill, time, and resources into creating one of its most intricate artistic and political statements, only to bury it completely intact, almost immediately after completion? The story begins in 2013, when archaeologist Francisco Estrada Belli and his team were excavating Structure 1 at the ancient Maya city of Holmul. At first, the excavation appeared routine. Like many Maya cities, Holmul was built in layers, with newer constructions rising directly over older ones, forming complex pyramidal structures over centuries. But as the team dug deeper into the stratigraphy, something unexpected began to emerge from beneath the compacted fill. A massive stucco facade, still intact, still coherent, and almost impossibly well preserved. What they uncovered was a frieze stretching approximately 8 meters in length and nearly 2 meters in height, carved entirely from lime-based stucco. It dated back to the 6th century, roughly the year 590 of the Common Era, placing it firmly within the late Classic period of Maya civilization. Unlike fragmented remains typically found at similar sites, this was not a broken artifact or scattered debris. It was a complete visual composition, an uninterrupted narrative frozen in time. At its center stood a ruler, richly adorned, wearing an elaborate headdress that signified divine authority. Surrounding him were massive mask-like figures, likely representations of deities or cosmological entities, along with intricate geometric and symbolic patterns. Traces of red pigment remained visible across the surface, suggesting that the entire composition was once vividly colored. Even after more than 14 centuries underground, the facial expressions, contours, and fine carvings retained remarkable clarity. From a scientific standpoint, the preservation of this frieze presents one of its greatest mysteries. Stucco, composed primarily of calcined limestone mixed with water and organic additives, is highly vulnerable to environmental degradation. In tropical regions such as Guatemala, high humidity, rainfall, and biological activity typically erode such materials within a few hundred years. For comparison, stucco reliefs at major sites like Tikal and Calakmul have suffered extensive surface loss, often leaving only faint outlines of their original forms. Yet at Holmul, the frieze remains sharply defined, with depth and detail rarely seen in Maya art of comparable age. This raises a critical question grounded in material science. Was the preservation simply the result of rapid burial creating a sealed microenvironment, or did the Maya possess a more sophisticated method of producing stucco than we currently understand? Chemical analyses suggest a mixture of lime plaster enhanced with organic binders, possibly derived from plant extracts. However, the exact formulation, and more importantly, the preparation techniques remain uncertain. Some researchers have drawn cautious comparisons to ancient Roman concrete, which exhibits long-term durability due to complex chemical reactions within its composition. Yet unlike Roman structures, which often benefit from marine mineral interactions, the Holmul frieze survived in a humid jungle, an environment typically hostile to long-term preservation. As excavation continued, further evidence reinforced the idea that this was not an accidental survival. The structure surrounding the frieze showed clear signs of intentional construction phases. After the frieze was completed, it was carefully encased within a newer architectural layer. There were no signs of destruction, no evidence of collapse, and no indication that the site had been abandoned at the time of burial. Instead, the builders deliberately sealed the frieze within the structure, effectively removing it from visibility. This phenomenon, often referred to as building over, is well documented in Maya architecture. Temples were frequently expanded, with new layers constructed over older ones as part of continuous urban and ceremonial development. However, in most cases, earlier structures were partially dismantled or repurposed. At Holmul, the situation is fundamentally different. The frieze was not altered, damaged, or reused. It was preserved in its entirety, as if the act of burial itself was intentional and meaningful. This leads directly to the central mystery of the Holmul Frieze Temple. Why create something so detailed, so symbolically rich, only to conceal it almost immediately? The imagery itself offers possible clues, but also deepens the uncertainty. The central figure is widely interpreted as a divine ruler, possibly representing the concept of the Kuhul Ajar, the holy lord who embodied both political and spiritual authority. The surrounding masks may represent supernatural beings, possibly linked to creation myths or cosmological cycles. The composition is highly symmetrical, with both sides mirroring each other in near-perfect balance, suggesting advanced planning and precise execution. Yet despite these identifiable elements, not all symbols conform to known Maya iconography. Some motifs appear rare or unique, lacking direct parallels in other sites. This raises the possibility that the frieze encodes a localized or specialized symbolic system, perhaps tied to a specific dynasty, ritual event, or political moment that is not fully documented elsewhere. Without accompanying glyphic inscriptions, interpretation becomes significantly more difficult. Unlike stele or codices, which often provide textual context, the Holmel frieze communicates almost entirely through imagery. Several hypotheses have been proposed to explain both the imagery and the burial. One interpretation views the frieze as a form of political propaganda, designed to legitimize a ruler by associating them with divine forces. In this framework, the elaborate iconography serves to reinforce authority and project cosmic order. However, this explanation introduces a contradiction. Political messages are typically intended to be seen, to influence an audience. Concealing such a message undermines its purpose. An alternative hypothesis suggests that the frieze had a ritual function. In many ancient cultures, including the Maya, construction itself could be a sacred act, with buildings serving as both physical and symbolic structures. The burial of the frieze may have been part of a ceremonial process, transforming it from a visible artwork into a hidden, sacred element embedded within the architecture. This aligns with broader patterns of ritual deposition, where valuable or meaningful objects are intentionally buried as offerings or as part of cyclical renewal practices. Yet even this explanation leaves unanswered questions. The level of detail and craftsmanship invested in the frieze implies a significant allocation of resources, including skilled labor and time. Why devote such effort to something that would never again be seen? Additional discoveries at Holmel provide context but not definitive answers. Excavations have revealed evidence of trade networks, ceramic production, and interactions with larger regional powers, including Tikal. Radiocarbon dating confirms that the site was active during a period of political complexity, marked by shifting alliances and regional competition. It is possible that the frieze commemorated a specific event, such as a royal accession, alliance, or victory, that later became politically sensitive or irrelevant, leading to its deliberate burial. However, no direct evidence supports this theory conclusively. The Holmel frieze remains an anomaly, a fully preserved artifact whose context is partially understood, but whose purpose remains ambiguous. From a broader perspective, the frieze challenges assumptions about technological and artistic capabilities in ancient societies. The precision of its symmetry, the durability of its materials, and the sophistication of its iconography all suggest a level of expertise that is often underestimated. While it does not imply the existence of lost advanced technology in a modern sense, it highlights gaps in our understanding of how knowledge was developed, transmitted, and applied within the Maya world. So what do you think? Was this a political message, a sacred ritual, or something we still completely misunderstand? Share your thoughts in the comments below. At the northern edge of Egypt's Fayum, depression lies Soknopayu Nessos, a lost Greco-Roman city swallowed by sand for nearly 2,000 years. Known today as Dimei el-Siba, the site sits more than 80 kilometers southwest of Cairo near the ancient shores of Lake Moeris. Unlike most Egyptian settlements that depended directly on the Nile, Soknopayu Nessos was built deep inside an isolated desert basin where survival should have been nearly impossible. The ruins were first documented in detail during the late 19th century by explorers such as Grenfell and Hunt, who later uncovered enormous quantities of papyri preserved beneath the dry sand. Excavations throughout the 20th century revealed something unexpected. This was not a minor desert village. but a highly organized religious and economic center covering several hectares, complete with paved ceremonial roads, massive mud brick architecture, underground storage systems, and a monumental temple dedicated to the crocodile god Soknopaios. But the deeper archaeologists excavated, the stranger the city became. The greatest mystery was simple. How did a large urban population survive for centuries in one of the harshest environments in Roman Egypt? The first major mystery surrounding Soknopaiou Nessos is water. Modern Fayum is largely arid, and the northern desert surrounding the city receives almost no rainfall. Annual precipitation in the region today is often below 20 millimeters. Summer surface temperatures can exceed 40 degrees Celsius, while evaporation rates are among the highest in North Africa. Under these conditions, sustaining a permanent settlement would normally require direct river access or advanced hydraulic infrastructure. Yet Soknopaiou Nessos flourished between roughly the 3rd century BCE and the 3rd century CE. Archaeological surveys discovered traces of canals, reservoirs, and carefully engineered water control systems buried beneath layers of sand. What puzzles researchers is the precision of these constructions. Some canals appear to maintain extremely subtle gradients over long distances, allowing water to move slowly without rapid loss from erosion or evaporation. Hydrologists comparing the site to Persian Khanate systems and Nabatean engineering at Petra have noted remarkable similarities in environmental adaptation. However, Soknopaiou Nessos existed in a very different geological setting. Fayum soil contains unstable sediments that shift constantly with wind activity. Maintaining long-term canal efficiency in such terrain would have required continual recalibration and advanced practical understanding of sediment movement. Satellite mapping and geological studies suggest the inhabitants may also have exploited fluctuations in the ancient Lake Moeris water level. During certain historical periods, the lake expanded significantly, potentially feeding hidden irrigation routes connected to agricultural zones outside the city. Some scholars believe the settlement functioned almost like a carefully balanced ecological machine, surviving only because its inhabitants mastered an unusually precise relationship between climate, groundwater, and seasonal flooding. Even today, researchers still debate exactly how the system worked. The layout of Soknopaiou Nessos raises another extraordinary possibility. The city may have been intentionally engineered to manipulate airflow and temperature. Unlike many ancient settlements that evolved organically over centuries, Soknopaiou Nessos followed a surprisingly rigid urban axis centered on the temple complex. Streets were narrow, walls were unusually tall, and residential clusters formed enclosed corridors that limited direct sunlight during the hottest hours of the day. Climate archaeologists studying the ruins have proposed that these arrangements created passive cooling effects similar to those used in traditional Middle Eastern wind tunnel architecture. By forcing desert winds through constricted passageways, the city may have generated localized pressure differences that reduced heat accumulation. Thermal studies of ancient mud brick structures show that dense earthen walls can delay heat transfer by several hours. In desert climates, this means interiors remain relatively cool during the day and release stored heat only after sunset. Some buildings at Soknopaiou Nessos appear optimized for exactly this effect. This has led to comparisons with later Persian Badgir wind towers and even certain Roman bath ventilation systems. But Soknopaiou Nessos predates many of those developments in North Africa. If the theories are correct, the city represents one of the earliest known examples of large-scale passive environmental engineering in a desert settlement. The mystery deepens when examining the temple road itself. The main ceremonial avenue appears aligned in a way that reduces direct sand accumulation from prevailing winds. Some archaeologists suspect the builders intentionally studied wind direction over long periods before construction began. That level of environmental planning would have been astonishing for its time. Most ancient mud brick cities deteriorate rapidly once abandoned. Wind erosion, thermal expansion, and salt crystallization gradually destroy exposed walls. Yet major sections of Soknopaiou Nessos remained standing for nearly 2 millennia despite extreme desert conditions. Material analysis revealed something unusual in the composition of certain bricks. Researchers identified mixtures containing varying ratios of clay, straw, mineral salts, and organic additives that may have improved structural flexibility under repeated temperature stress. Some bricks show microscopic resistance to cracking that exceeds what archaeologists normally expect from standard Greco-Roman mud brick construction. The phenomenon has drawn comparisons to other mysterious ancient building technologies, including Roman pozzolanic concrete and Persian sarouge mortar. Like those materials, the exact production methods at Soknopaiou Nessos remain uncertain because ancient manufacturing records are incomplete. One theory suggests local builders exploited Fayum's naturally saline sediments to create partial self-hardening effects inside the brick matrix. Another proposes that repeated cycles of controlled drying may have strengthened the material before construction. Whatever the explanation, the city demonstrates a level of practical materials engineering far beyond what many historians once assumed for remote desert settlements. Beneath the visible ruins lies one of the site's most controversial mysteries. Excavations uncovered networks of underground chambers, tunnels, and storage spaces extending below residential and ceremonial areas. Some rooms maintain noticeably lower temperatures than the desert surface, even during extreme summer heat. Measurements in similar subterranean desert structures show temperature differences of more than 10 degrees Celsius compared to surface conditions. This has led researchers to speculate that Soknopaiou Nessos may have used passive underground cooling systems for food preservation, document storage, or ritual activities. The theory is supported by one remarkable fact. Enormous quantities of papyri survived at the site in exceptional condition. Papyrus is extremely vulnerable to humidity fluctuations, biological decay, and thermal damage. Yet thousands of documents remained readable after nearly 2,000 years buried beneath the sand. The dry climate certainly contributed, but some archaeologists believe the storage architecture itself played a major role. Certain chambers appeared deliberately sealed from rapid airflow while maintaining stable underground temperatures. If intentional, this would represent a sophisticated understanding of microclimate control centuries before modern environmental storage science. The implications are extraordinary. Soknopaiou Nessos may not simply have been storing goods underground. It may have been engineering artificial preservation environments inside the desert itself. At the heart of the city stood the massive temple of Soknopaios, a crocodile deity associated with fertility, protection, and water. But the temple's architecture contains anomalies that continue to fuel debate. Researchers observe that sunlight enters certain parts of the temple at unusually precise seasonal angles. During particular times of the year, narrow shafts of light illuminate inner ceremonial spaces while surrounding chambers remain in darkness. This phenomenon has led to comparisons with Egyptian solar alignments at Abu Simbel, Dendera, and Karnak. However, Soknopaiou Nessos was far more isolated than those major religious centers. Some historians argue the alignments were symbolic, reinforcing the divine authority of the temple priesthood. Others believe they may have served practical calendrical purposes linked to agriculture and water management. No consensus exists because much of the upper temple structure has collapsed. Still, the surviving geometry strongly suggests intentional astronomical planning rather than coincidence. If true, the city combined hydraulic engineering, climate adaptation, and celestial observation into a single integrated urban system. What do you think really caused the sudden disappearance of Soknopaiou Nessos? Environmental collapse, economic decline, or a hidden factor we still haven't discovered? Share your theory in the comments below. West of the Nile in modern Luxor, Egypt, Valley of the Artisans looks insignificant from a distance. But beneath this desert settlement lies one of the strangest technological mysteries of the ancient world, a village where ordinary workers may have possessed engineering knowledge centuries ahead of their time. The site, also known as Deir el-Medina, was systematically excavated during the late 19th and early 20th centuries by archaeologists including Ernesto Schiaparelli and Bernard Bruyère. What they uncovered was astonishing. Thousands of tools, sketches, medical records, pay logs, architectural plans, and underground tombs belonging not to kings, but to the craftsmen who built the royal tombs of the New Kingdom between roughly 1550 and 1070 BCE. The deeper archaeologists explored, the more impossible the site seemed. Most ancient labour settlements discovered across the world were temporary, chaotic, and poorly organised. Deir el-Medina was the complete opposite. The village was planned with geometric precision, with houses aligned in organised rows and workers divided into specialised construction teams. Written records reveal fixed salaries paid in grain, beer, fish and oil, while surviving papyri describe medical leave systems, legal disputes, and even what many historians consider the first recorded labour strike in history during the reign of Ramesses III around 1155 BCE. Compared to ordinary Bronze Age settlements in Mesopotamia or the Levant, which often lacked centralised planning and permanent infrastructure, Deir el-Medina operated more like a secured industrial complex. This evidence challenged older theories claiming Egypt's monuments were built purely by massive slave populations. Instead, the settlement suggests the existence of a highly trained technical class, operating almost like a state-protected engineering corps. But the true mystery was hidden beneath the desert surface. Inside the tombs of Deir el-Medina, archaeologists discovered pigments that remained vividly blue after more than 3,000 years beneath desert heat, salt exposure, and violent temperature fluctuations. The pigment was known as Egyptian blue, and modern laboratory analysis revealed that it was far more advanced than ordinary paint. Egyptian blue is actually a synthetic crystalline material created by heating silica, copper compounds, calcium, and natron at temperatures between approximately 850 and 1000 degrees Celsius. Maintaining such stable temperatures in the Bronze Age should have been extraordinarily difficult because even slight instability during firing could destroy the crystalline structure responsible for the pigment's colour. What shocked scientists even more came in the 21st century when researchers discovered that Egyptian blue emits strong near-infrared luminescence when exposed to visible light. In other words, the material behaves similarly to advanced optical compounds used in modern imaging technologies. Under infrared cameras, the pigment effectively glows beyond the visible spectrum, allowing damaged artworks to be detected even when the blue colour has faded from human sight. Some materials scientists compared this accidental property to modern photoluminescent engineering and infrared nanomaterials. The mystery is not simply that ancient Egyptians created blue pigment. The real mystery is that a civilization over 3 millennia ago unintentionally produced a technologically sophisticated optical material, requiring precise thermal chemistry and microscopic crystalline control. Even today, reproducing authentic Egyptian blue using ancient methods remains extremely difficult. Experimental archaeologists repeatedly struggle to recreate the exact texture, durability, particle structure, and infrared behavior found in original samples from Deir el-Medina. What makes the site even stranger is the consistency of production. The pigment appears across multiple tombs with remarkably stable quality, implying standardized industrial methods rather than isolated experimentation. Compared to most ancient pigments, which faded rapidly under moisture or sunlight, Egyptian blue survived for millennia with unusual chemical stability. This suggests that the artisans of Deir el-Medina may have possessed specialized material knowledge that effectively disappeared after the decline of ancient Egypt. The wall paintings inside many artisan tombs remain astonishingly preserved despite centuries of earthquakes, moisture migration, and extreme desert heat cycles that can exceed 40 degrees Celsius during summer days. Normally, painted plaster expands and contracts over time, producing fractures, surface separation, and pigment loss. Yet many Deir el-Medina murals remain unusually intact compared to wall paintings from other ancient civilizations of similar age. Modern analysis indicates that the craftsmen may have used multi-layer plaster systems with varying densities and mineral compositions. Some researchers compare the structure to primitive composite engineering, where different material layers absorb stress differently to reduce cracking. Microscopic studies found extremely fine gypsum particles combined with carefully controlled organic binders. Certain walls also show evidence of repeated polishing phases before painting even began. The process resembles precision surface preparation later seen in Roman fresco construction centuries afterward, except Deir el-Medina predates many comparable techniques by hundreds of years. In some tombs, pigments penetrated unusually deep into prepared plaster layers, helping the colors survive environmental damage far longer than expected. No surviving written manual fully explains how the artisans achieved this durability, and many modern restoration specialists still debate the exact composition of the original materials. The tombs themselves raise even more questions. These underground chambers were carved directly into limestone hillsides, using tools primarily made from copper and stone, yet many passageways maintain striking geometric consistency over long distances. Some chambers display alignment errors of only a few centimeters across several meters of excavation. Archaeologists discovered red guideline markings and mathematical grid systems on unfinished walls, proving the workers used advanced planning methods rather than improvisation. The proportional systems used in some tomb artwork were so accurate that researchers compared them to later Greek geometric standards. The cutting precision becomes even harder to explain when examining polished stone surfaces inside certain chambers. Copper measures only around 3 on the Mohs hardness scale, while quartz-rich abrasives commonly found in Egyptian sandstone can reach hardness levels near 7. This led researchers to conclude that workers likely used quartz sand as an industrial abrasive during cutting and smoothing operations. However, another mystery emerges from that explanation. The amount of labor required to achieve such uniform finishing entirely through manual abrasion would have been enormous. Some surfaces appear far smoother than expected for known Bronze Age methods. Compared to rougher tomb interiors found in many other ancient cultures, the finishing quality at Deir el-Medina appears unusually controlled and systematic. To this day, debates continue over whether lost polishing techniques once existed within specialized Egyptian craft guilds. One of the oldest mysteries surrounding Egyptian underground construction also appears at Deir el-Medina. How did workers illuminate deep tomb corridors without covering ceilings in soot? Traditional explanations claim they used low-smoke oil lamps combined with polished copper reflectors, and some experiments demonstrate that this method is theoretically possible in small spaces. However, several chambers extend deep into enclosed rock systems, where ventilation was poor and reflective lighting efficiency would have decreased dramatically. Yet many ceilings contain surprisingly little soot residue. Certain fringe theories propose unknown lighting technologies, though mainstream archaeologists reject such claims because no direct evidence exists. Still, the practical problem remains difficult to fully explain. Artists painted highly detailed scenes deep underground for extended periods, while apparently maintaining visibility and breathable air. Even controlled modern recreations often struggle to replicate the same working conditions efficiently using only traditional oil lamps. Compared to Roman catacombs and other underground ancient sites where soot traces are much more visible, some Egyptian tomb chambers remain unusually clean. Perhaps the strangest aspect of Deir el-Medina is how isolated its knowledge appears to have been. The village operated almost like a secret technological complex where artisans lived separately and royal tomb construction was tightly controlled. Many techniques found here rarely appeared elsewhere in ancient Egyptian settlements, and when royal tomb building declined, much of that knowledge may have disappeared with the workers themselves. Do you think the artisans of Deir el-Medina possessed lost technological knowledge far beyond what historians officially believe today? Share your thoughts and theories in the comments below.